Hello aspirants, welcome to Environment course by UPSC experts. This is class 11 of the course. Let's go to the class notes and start with class 11. We were discussing about climate change mitigation strategies, right? In last class, we have discussed about carbon sequestration, and in this class, we will be discussing about renewable energy, carbon trading, and geoengineering, right? See, these two are very important, right? We need to understand carbon trading and all the aspects of carbon trading and renewable energy, right? These two are climate change mitigation strategies, right? So let's start with renewable energy, right? We will be discussing the important renewable energy, right? See, renewable energy, right? Renewable energy is energy derived from natural sources that are replenished at a higher rate than they are consumed, that are replenished at an higher rate than they are consumed, replenished at an higher rate than they are consumed, right? Renewable energy sources are plentiful, right? And all around us, right? Example: solar energy, wind energy, hydropower, geothermal energy, ocean energy, bioenergy, etc. So we'll be dealing with one by one, right? We'll understand what is solar energy, right? How much is there in India and all. We'll be discussing it. See, current state of renewable energy in India. Current status of renewable energy in India. The share of renewable energy in the total installed generation capacity is 43%, right? So 43% of our energy is from renewable sources. That is 43% of the electricity we are consuming at now is 43% is from renewable sources. At present, India's renewable energy capacity is 203 gigawatts, right? 203 gigawatts, right? Now, see, it includes solar power. So, out of the renewable energy sources, highest is solar power. Then, after that, we have hydropower. Hydropower is divided into large hydropower and small hydropower. So, combined, it is 47 plus 5, that is 52 gigawatts, right? 52 gigawatts. Then wind power is 46 gigawatts. Then biopower is 11 gigawatts, and waste to energy is 0.60 gigawatts, right? So first is solar, then hydro, then wind, right? Then biopower, all the other things, right? So first three we need to remember, right? We need to remember this data. Then under Panchamrita strategy announced by India at COP26 of UNFCCC. We will be studying at COP26, right? When we study about UNFCCC, right? Held in Glasgow, India committed to, so under Panchamrita strategies, India committed 5 things. That is, increase in non-fossil energy capacity to 500 gigawatts by 2030, right? So 500 gigawatts by 2030. See, right now it is 203 gigawatts, right? So non-fossil with 2030 target is 500 gigawatts, right? Then meet 50% of its energy requirements from renewable energy by 2030. See, right now we are having 43% of our energy requirements from renewable energy. So that needs to be increased to 50% by 2030, right? Then reduce the total projected carbon emissions by 1 billion tons from now till 2030. So 2030 tak 1 billion tons of carbon emissions reduce karna hai, right? Then reduce the carbon intensity of its economy by less than 45% by 2030, right? So reduce the carbon intensity reduce karna hai by 45%. Then achieve the target of net zero, that is overall there is zero emission by 2070. So here the year is important, rest everything is 2030 tak hai, right? So this net zero is by 2070, right? See, anytime they can ask this, right? Or Panchamrit 5 things they can ask, or any few things they can ask, right? So here you will be remembering it, that is carbon neutrality by 2070, right? So they can give 2030 or 2050, right? But it is by 2070 tak net neutrality lana hai. That is the target, right? Now let's study renewable energy sources one by one. Let's see. First, let's study about solar energy, right? Study about solar energy. So what is solar energy? Right? Solar energy can be indirectly or directly converted into electricity through following two systems. Right? Basically, solar energy is we are using solar energy, sun's energy, sunlight to generate electricity. That is solar energy, right? So we can use two systems to generate electricity from solar energy. So first is solar thermal power plant system, that is solar thermal power systems, and or it is also called as concentrating solar power systems. Concentrating solar power systems, right? So here what happens is this system concentrates the rays of sun, right, using mirrors, lenses, etc. to heat the liquid. This liquid is mostly water to convert it into steam, right? To convert a liquid into steam, that is, see, by using mirrors, right, we concentrate sunlight, right, sunlight onto the water, right? पानी में sunlight concentrate करके डालेंगे और उस heat से, with that heat, that liquid is converted into steam. That liquid is converted into steam, and the steam is then used to turn the turbine to create electricity. So the steam is used. See, in thermal power plant what happens, right? जैसे जो coal based thermal power plants है उसमें भी हम लोग क्या करते हैं, see, coal we take it and we make it a coal powder, right? जो कोल है उसको पाउडर फॉर्म में बनाएंगे, देन उसको यूज करके कोल पाउडर को जलाएंगे, राइट, टू बॉयल वाटर. So this water gets converted into steam, right? And steam, when we boil water, steam is at high temperature, and at high temperature the steam helps in turbine rotation, right? And with this turbine rotation we get electricity, we can generate electricity. So that is the principle. So anything, if we need to generate electricity, right, it can be directly sunlight we can generate, or टर्बाइन घुमा के इलेक्ट्रिसिटी जनरेट कर सकता है, राइट? इन विंड एनर्जी आल्सो वी विल रोटेट द टर्बाइन, राइट? इन hydro electricity also, hydro power also, we will rotate the turbine, right? So this is the basic. So either we coal thermal power, maybe we are rotating the turbine. So rotating turbine we create electricity. So here also we are using solar energy, right, rather than coal. ठीक है, इधर coal use नहीं कर रहा है. Rather than using coal, we are using concentrate sun rays to boil water. Concentrated sun rays to boil water, that is leading to concentrate rays of the sun using mirrors, lenses, etc. to heat the liquid to convert it into steam, right? To convert it into steam, right? Example of this is Dursar concentrating solar power in Jaisalmer, Rajasthan. So in Jaisalmer, Rajasthan, we are using it, right? So this is one, that is solar thermal power systems. Solar thermal power, so thermal power ही है, right? Water को boil करके we are getting it, but we are using solar thermal, that is coal thermal power plants, right? We used to call, right? Or concentrating solar power systems, concentrating sun rays, right? That is called concentrating solar power systems. Then next is solar photovoltaic. See, this is first type, right? Then second is solar photovoltaic, जो solar energy, solar panels use करके we create electricity, that is solar photovoltaic, right? So let's study that, right? Solar photovoltaic, right? See, this system can directly convert the sunlight into electrical energy through use of photovoltaic cells. See, this system can directly convert the sunlight into electrical system through use of photovoltaic cells. Photovoltaic cells use करके, right? जैसे solar panel है, right? Solar panel, when sun rays strike the solar panel. Solar panels are made of silicon, right? Solar cells लगा हुआ है, right? So and each cell has 3 layers. PN junction, we don't need to know its technical aspects, right? So when sun rays fall, the silicon elements, solar panels, they directly generate electricity. ये important है, directly generate electricity. तो इधर ही electricity generate करेंगे, which can be collected in the inverter, right? we can collect and we can then directly sunlight से we convert it into AC current, right? ये DC current है, जो directly current है वो DC current है. So DC current को हम AC में convert करके then we will be distributing it to other things. जो भी use करना है उसको use करेंगे, right? So this is the way. So direct current generate होगा. So where solar photovoltaic, right? जो solar panels से will this system can directly convert sunlight into electrical energy through use of photovoltaic cells. Then see, India is the fourth largest solar energy producer globally. India is fourth largest solar energy producer globally. Right? Globally fourth largest producer hai. Right? So now let's do questions. See, this is question asked in UPSC 2014. That is, with reference to technologies for solar power production, consider the following statements. That is, photovoltaics, right? Technologies of solar power production. Consider the following statements. That is, photovoltaics is a technology that generates electricity from direct conversion of light into electricity. Photovoltaics is a technology that generates electricity by direct conversion of light into electricity, right? We have studied, right, photovoltaics, that is solar panels, while solar thermal is a technology that utilizes sun rays to generate heat, which is further used in electricity generation. Yes, this is correct point. That's what we studied, right? So solar thermal mein, right, solar thermal is this one, right? Solar thermal power systems. So solar thermal mein, see, photovoltaics is a technology that generates electricity by direct conversion of light into electricity, right? While solar thermal is a technology that utilizes the sun's rays to generate heat, which is further used in electricity generation process, right? Then photovoltaics generate alternate current while solar power generates direct current. See, we have studied photovoltaic generate direct current, right? Directly generate, then alternate current में change करके फिर distribute करेंगे, right? While solar thermal generates direct current, no, right? It doesn't generate. solar thermal ये टर्बाइन को रोटेट करने में स्टीम को गर्म करती है, right? It doesn't generate any electricity, right? So or direct नहीं. So now India has a manufacturing base of solar thermal technology but not photovoltaics. No, we have manufacturing base for photovoltaics also, right? And we have manufacturing base for solar thermal technology also. Solar thermal technology we have manufacturing base, right? So either hai already, right? So option 1 only is correct, right? So option A is the answer. Let's check it. See, solar energy can be indirectly and directly converted into electricity through two ways. That is solar thermal. Here sun rays used to heat the liquid to convert it into steam. Okay? The steam is then used to turn turbine to create electricity, right? That is solar thermal. Then next is solar photovoltaics. Here sunlight is directly converted into electrical energy using photovoltaic cells. So solar photovoltaics. Here sunlight is directly converted into electrical energy, right? Sunlight is directly converted into electrical energy using photovoltaic cells, right? Sunlight is directly converted into electrical energy using, so directly we are using. So here we produce direct current, right? So this is the fact you need to remember, right? Then solar photovoltaic converts sunlight directly into electricity through photovoltaic effect, right? Through photovoltaic effect जो बोलते हैं उसको photovoltaic effect. See, basically there are PN junction, right, are there. They basically electrons release करती है to provide electricity, right? So the term photovoltaics is derived from the conversion of light, that is photons into electricity voltage, a phenomena known as photovoltaic effect, right? So direct current release करती है, ये that we need to remember. PV cells are made up of semiconductor materials like silicon. When sunlight strikes the cell, sunlight cell बनाया, right? When sunlight strikes the cell, electrons are knocked loose from the atoms, generating electricity. So electrons जब भी sunlight strike करेगा, electrons electrons are knocked loose from the atoms, right, generating electricity. So photovoltaics generates direct current. Photovoltaics generate direct current, and solar thermal does not generate any current. Solar thermal does not generate any current. Rather, it heats up water and convert it into steam. Right? So solar thermal कुछ वो नहीं करेगी. Right? It heats up water. So the steam is then used to turn the turbine to create electricity. Right? Then next is India has a manufacturing base of solar thermal technology as well as photovoltaics. So photovoltaics ka bhi we have a manufacturing technology, right? So option A is the correct answer. That is one only is the correct, right? Now let's see next question. So this is question asked in UPSC 2018. That is with reference to solar power production in India. Solar power production in India. India is the third largest in the world in manufacturing of silicon wafers used in photovoltaic units. See now let's understand. ठीक है, silicon wafers क्या होता है, right? Silicon wafers. See, India is the third largest in the world in manufacturing of silicon wafers used in photovoltaic units. See, solar panel जो है, ठीक है, it is say like this, right? Right? See, this one unit, it is called cell, solar cell, right? Solar cell, and this the entire sheet is called module, right? Sheet is called module, right? So each cell generates its own electricity, right? So each cell generates its whenever strike करेगा, each cell electrons आएंगे, electrons सब इनमें इकट्ठा होके फिर will get direct current, right? That is a module. Electrons will create direct current, right? So silicon wafers are what? Silicon wafers are each cell is made up of silicon, right? So each cell is made up of silicon, and each cell में there are 3 layers. ठीक है, जो पतला सा 3 layers होंगे. एक में होगा p junction, एक में होगा n junction, and pn junction बनके they will release electrons, right? So no need to go into the technicalities. हमें just ये थोड़ा silicon wafers क्या है वो समझना है बस. Let's read the explanation. See, manufacturing of solar panels called modules. So इनको ही solar panels, पूरा module को ही solar panel बोलता है. See, this entire thing is one panel, right? जो stand में separate panels लगते हैं ना, so right? So here one more panel can be there, right? So manufacturing of solar panels, also called modules, start with polysilicon which is made from silicon. So silicon से बनता है basically most of the solar panels. So polysilicon is made into ingots. So जो silicon है, right? So that is made into ingots which are cut into wafers, right? Which are cut into wafers, right? Ingots को wafers में बनाएंगे. Then cells are made with wafers. So wafers से we make cells, right? So with wafers we make cells, right? And using a string of cells is a module. So string of cells. So basically हम जो cell बनाता है वो silicon wafers use करके बनाता है, right? We use wafers to make cells, right? And a combine of many cells is called module or panel, right? So today only modules and cells are made in India with imported material. So today we only make modules and cells. So that means we only make these cells, right? We only make these cells, and the entire cells को मिला के modules बनाता है. Silicon wafers we don't even make, right? जो silicon है हमारे पास है नहीं, manufacturing of silicon wafers भी है नहीं. And if we see, the third largest producers of silicon wafers is China is the world's largest silicon producer, followed by Russia, Norway, USA and Brazil. So India is not there among the list. By India, solar चीजें related mostly it imports, right? So that is the thing. Now the next option, so first option is incorrect because we are not manufacturing silicon wafers. We only manufacture cells and modules from the imported material, right? Then the solar power tariffs are determined by Solar Energy Corporation of India. It is incorrect. Now let's see, right? So option D is the answer. Now let's see solar tariffs कौन determine करता है. See, solar power tariffs are not determined by Solar Energy Corporation of India. Rather, solar power tariffs are determined either through regulations of Central Electricity Regulatory Commission or State Electricity Regulatory Commission or through competitive bidding. So या तो स्टेट इलेक्ट्रिसिटी रेगुलेटरी कमीशन होगा या सेंटर इलेक्ट्रिसिटी रेगुलेशन स्टेट इलेक्ट्रिसिटी रेगुलेशन कमीशन और थ्रू competitive bidding. So these are the three ways where solar power tariffs are determined in India, right? Then let's study about Central Electricity Regulatory Commission, right? So हम इस क्वेश्चन में see we will study about Central Electricity Regulatory Commission and we will also study about the option that is Solar Electricity Corporation of India. इसके बारे में भी पढ़ते हैं, right? See, I make sure that we discuss everything given in the question in our explanation of PYQs, right? So क्योंकि next time कभी भी Solar Electricity Corporation of India question आ सकता है, right? So we must prepare that, right? So Central Electricity Regulatory Commission is a statutory body established by Government of India under the provision of Electricity Regulatory Commission Act 1998, right? Then बाद में Electricity Regulation Commission Act is repealed, right? Was repealed. So now CERC, that is Central Electricity Regulatory Commission, is the Central Commission for Electricity Act 2003, right? So अभी it functions, Central Electricity Regulatory Commission functions under Electricity Act 2003, right? 2003. So it is now also it is a statutory body, right? It works under Ministry of Power, right? It works under Ministry of Power, right? Then composition is chairperson and 4 members, 1+4. Then functions is to regulate the tariffs of generating companies owned or controlled by central government. So it regulates tariff, right? To regulate interstate transmission of electricity. So within the transmission of electricity between different states, जैसे मान ले say we need to transmit electricity from say Madhya Pradesh to Rajasthan, right? So that is regulated by Central Electricity Regulatory Commission, Central Electricity Regulatory Commission, right? So interstate transmission of electricity to determine tariff for interstate transmission of electricity. Whenever there is transmission between two states, जो कितना tariff होगा उस transmission के लिए, so that is also determined by Central Electricity Regulatory Commission, right? So that is the thing about Central Electricity Regulatory Commission, which is a statutory body right now under the Electricity Act of 2003, right? So now let's go to this and study about Solar Electricity Corporation of India. See, again very important question, कभी भी आ सकता है, right? Solar Electricity Corporation of India पे ही question आ सकता है, right? So now what is Solar Electricity Corporation of India? ये basically Central Public Sector Undertaking है, right? PSU, right? This is basically PSU, Central PSU है, so that's why it is called Central PSU, right? Central Public Sector Undertaking, basically Central Government का company है, right? Central Public Sector Undertaking dedicated to the development and expansion of renewable energy capacity of India, right? Then अब देखो ये सोलर एनर्जी नहीं, ये रिन्यूएबल एनर्जी कैपेसिटी ऑफ इंडिया को बढ़ाने के लिए वो क्यों है, वो दैट वी विल बी डिस्कसिंग, राइट? सो इट वाज एस्टैब्लिश्ड टू फैसिलिटेट इंप्लीमेंटेशन ऑफ नेशनल सोलर मिशन, ठीक है? देन इट इज अंडर द एडमिनिस्ट्रेटिव कंट्रोल ऑफ Ministry of New and Renewable Energy. Ministry of, again we need to remember it. So it is under the administrative control of Ministry of New and Renewable Energy. Then it was incorporated in 2011. So it is found in which year, right? It is in 2011, right? So 2011 as a not for profit company, okay? Not for profit company, but under section 25 of Companies Act. But now it is converted into a commercial company in 2015. So 2015 it is converted into commercial company. So अभी ये option देगा कि it is a not for profit organization, तो that is incorrect. Now it is a commercial company under section 3 of Companies Act 2013, right? So it is a commercial company, राइट? पीएसयू है, इनका प्रॉफिट वगैरह भी इंपॉर्टेंट है. सो कमर्शियल कंपनी, नॉट फॉर प्रॉफिट कंपनी नहीं है, राइट? सो दैट वी नीड टू रिमेंबर, राइट? नाउ इट इज नॉट ए नॉट फॉर प्रॉफिट कंपनी, सो रेदर इट इज ए commercial company. Again, very important point. Then It is the only CPSU, Central Public Sector Undertaking, dedicated to the renewable energy sector. Dedicated to the renewable energy sector. Only Central Public Sector Undertaking. Right? Then Central, yeah, right? Solar Electricity Corporation serves as an implementing agency for the development of solar, wind, and hybrid projects. So this doesn't just deal with solar energy, so it also deals with solar, wind, and hybrid projects as part of fulfilling the country's nationally determined contributions. Right? Then the company also has a power trading license. So that means this company can trade power. Right? That means power खरीद के किसी को बेच सकती है. Right? And profits कमा कर सकती है उससे. So company has a power trading license and is active in its domain through trading of solar power from projects set up under schemes being implemented in it. Through trading of solar power from projects set up under the schemes being implemented. Right? So basically trading of solar power कर सकती है. Right? So its model involves procuring energy from developers selected through competitive bidding. Right? It can procure solar energy कोई produce किया, it can procure through competitive bidding and selling it to electricity distribution companies. So it can sell it to discom companies under long-term purchase power agreements and power sale agreements. Right? So basically it can trade power. Right? It can buy and it can sell to discoms. Right? So SCCI has been accorded the status of Mini Ratna Category 1 CPSU. Right? Then it now oversees a massive 65 gigawatts of awarded generation capacity. Out of this, more than 60% is solar energy. Right? More than 60%, right, is solar energy, and the remaining capacity includes 16.3 gigawatts of wind energy and about 9 gigawatts of hybrid energy projects. And 9 gigawatts of hybrid energy products. So that means we need to remember भाई ये solar energy में भी deal करती है, wind energy में भी deal करती है, and hybrid energy में भी deal करती है. Right? So again देखो कितने scope है पूछने के लिए. Right? So it is CPSU. Right? It can involve in power trading licenses. Right? It deals with solar, wind, and hybrid. Right? And it is the only CPSU, and it is a commercial company working under Ministry of New and Renewable Energy. Right? So very important topic. Right? So now with this we are done with the solar energy. Right? Now let's understand about wind energy. Right? So wind energy, right, this is the kinetic energy of wind can be harnessed by converting it into mechanical energy or electrical energy. Right? Using suitable devices such as turbines. So basically what happens is, see, wind energy, so there is wind, see, like this, and there are three fan-like structures. Right? Three fan-like structures. So fans rotate, right? And either pura machine setup hoga. So inside this, right, here at the back of it, there will be turbine, right? So as the this fan rotates, this turbine rotates more quickly, right? Fan तो धीरे घूमेगा, but turbine जल्दी घूमेगा. And जैसे turbine घूमेगा, turbine घूमने से इधर हमें electricity generate होगा, right? So that is turbine घुमाना is the main mechanism, right? In most of the cases. So kinetic energy of the wind is harnessed by converting it into mechanical energy or electrical energy. Mechanical energy or electrical energy में convert होगा using suitable devices such as turbines. Suitable devices such as turbines. So wind energy is classified into, it is classified into onshore wind energy, right? Onshore wind energy and offshore wind energy. Onshore wind energy and offshore wind energy, right? So that is basically, that is, it refers to wind turbines located on land. जो भी ये चीज है, which if they are on land, that is called onshore wind, and if they are on ocean or some water body, refers to wind turbines located on water bodies, usually in the ocean, on the continental shelf or large bodies of water. They are called offshore wind energy, right? onshore wind energy and offshore wind energy, right? Onshore wind energy and offshore wind energy, right? So then offshore wind turbines are more efficient, more land for projects and a lack of physical interference. So ऑफशोर जो है, जो ओशंस में है, दे आर मोर एफिशिएंट, राइट? कुछ लैंड का ज्यादा जरूरत नहीं पड़ेगा, ओशन में लगा सकते हैं, राइट? एंड लैक ऑफ फिजिकल इंटरफेरेंस, राइट? इंडिया हैज फोर्थ हाईएस्ट इंस्टॉल्ड कैपेसिटी टू प्रोड्यूस विंड एनर्जी आफ्टर यूएसए, चाइना एंड जर्मनी. सो दिस इज फोर्थ हाईएस्ट, राइट? So wind energy is fourth highest, right? That also we need to remember. Then Tamil Nadu has the highest wind power generation capacity, right? And Tamil Nadu has the highest wind energy potential. Potential भी उधर ही है and generation भी उधर ही हो रहा है. And followed by Gujarat. Gujarat also has huge wind energy potential, right? Then more than 95% of commercially exploited wind energy potential is concentrated. Commercially exploited wind energy potential is concentrated in 7 states. That is Tamil Nadu, Gujarat, Maharashtra, Karnataka, Rajasthan, Andhra Pradesh and Madhya Pradesh. Right? So in 7 states में commercially viable wind energy potential है, वो 95% इधर है. Right? So that is about wind energy. Right? So easy. So India is the 4th largest producer and offshore wind energy is more efficient. Right? Then आता है hydropower energy. Hydropower energy, right? That is uses force of falling water, that is kinetic energy to move the turbine and produce electrical energy. See, जैसे dam है, right? Say there is a dam, so there is waterfall, right? So on dam, basically hydropower में what we do is we let, see, store water here. Say dam is constructed, so there is water storage here, right? And now we let this water fall, right? When the water is falling, so they fall on the turbine, right? So because of kinetic energy, water तेज से move होगा, so because of kinetic energy the turbine rotate होके हमें electrical energy generate करेगा. So कहीं भी है turbine घूमना है, right? So turbine rotates and create electrical energy. So it requires creation of dams, right? It requires creation of dams, but not always natural waterfalls can be used, right? Sometimes natural waterfalls also come, but mostly we construct dams and we let the water fall, right? So it is relatively cheap source of energy. Because we can, if we use natural waterfalls, then it will be cheap. नहीं है तो डैम कंस्ट्रक्शन वगैरह में टाइम वो लगेगा, इन्वेस्टमेंट, उसके बाद ज्यादा वो लगेगा. सो प्रेजेंटली हाइड्रो पावर, दैट इज लार्ज एंड स्मॉल कंबाइंड, कंट्रीब्यूट्स टू 12% ऑफ इंडियाज टोटल एनर्जी मिक्स. सो अगेन वी हैव सीन, सी दिस इज द सेकंड लार्जेस्ट रिन्यूएबल एनर्जी, राइट? फर्स्ट इज सोलार के बाद हाइड्रो पावर, राइट? सो hydropower energy is classified into large hydropower projects and small hydropower projects. So power plants with capacity more than 25 megawatts are classified as large hydro, right? And large hydro projects have been declared as renewable energy source. So earlier they were not considered as renewable energy source. Now they are considered as renewable energy, right? Then plants with 25 megawatts or below are classified as small hydro, right? The hilly states of India, that is north and northeast, have highest potential for small hydro. That is, see, northeast India has very high potential of hydropower projects, right? So north and northeast, that is Uttarakhand, right? जहाँ hilly areas है, water flow भी है, right? There especially small hydropower projects का potential है. Small hydropower supply 5 gigawatts. So this current installed capacity of large hydro is 47 gigawatts. So total, that is 52 gigawatts of energy we are getting from hydropower, right? So that is with respect to hydropower. Then let's deal with geothermal power, right? So geothermal energy is what? Geothermal energy, see, that is geological thermal energy. That is the heat that comes from the subsurface of the earth. Earth के नीचे से, right? Heat आएगा, right? By using that we generate geothermal energy, right? To produce power from geothermal energy, wells are dug a mile deep up underground reservoir to access steam and hot water there, which can be used to drive turbines connected to electricity generators. See, basically कुछ नहीं है जियोथर्मल एनर्जी में. ठीक है, अर्थ में कुछ एरियाज में वी हैव हॉट स्प्रिंग्स जहां से गरम गरम पानी और स्टीम आती है बाय द नेचुरल हीटिंग प्रोसेस ऑफ द अर्थ. राइट, सो कुछ जगह में है. राइट, उधर से जब स्टीम बाहर आएगी, राइट, व्हेन वी डग वेल्स, उनको आइडेंटिफाई करेंगे, इधर है हॉट स्प्रिंग्स. राइट, हॉट स्प्रिंग्स वी आइडेंटिफाई एंड वी डग वेल्स. जब वेल डग करेंगे सो उधर से स्टीम आएगा, एंड वेन एवर स्टीम कम्स बिकॉज ऑफ हीट, इफ वी इंट्रोड्यूस टर्बाइन देयर, सो टर्बाइन विल बी रोटेटेड, राइट, कनेक्टेड, एंड इलेक्ट्रिसिटी जनरेट होगा, तो जनरेटर से इलेक्ट्रिसिटी खींच लेंगे. राइट, सो लाइक दैट वी जनरेट इलेक्ट्रिसिटी. सो नाउ जियोलॉजिकल सर्वे ऑफ इंडिया हैज ऑलरेडी आइडेंटिफाइड मोर देन 350 hot spring sites which can be explored as areas to tap geothermal energy. Right, then estimated potential of geothermal energy is 10,000 megawatts. Right, इतना ज्यादा है नहीं, 10,000 megawatts है. Right, so there are 7 geothermal provinces in India. Right, geothermal provinces where most of the geothermal springs, जैसे hot springs are concentrated. They are, one is Himalayas, second is Sohana is basically Gurugram area. ठीक है, वो उधर है. then west coast, right, then Cambay, then Son, Narmada and Tapi rivers के पास है, which are together called Sonata, ये region. right, then Godavari and Mahanadi. Right, see, let's see the map. Right, map of these areas. Right, you will get more clarity कि जो 7 geothermal provinces के बारे में. Right, so let's see the map. See, these are the geothermal provinces in India. Geothermal provinces in India. First is Himalayas. See, this is Himalayas, and this is Himalayas, and this is Himalayas. So this entire region, the yellow covered, so this is Himalayan region. Right, so this is one geothermal province. Right, so one geothermal province. Right, next is Sohana. See, Sohana is here. Right, that is Gurugram area of Delhi. Right, so Sohana is second geothermal province. Right, the third is West Coast. See, West Coast here, this is geothermal province, West Coast. Then fourth is Cambay is here. Right, West Coast idhar hai coast mein. Right, so Cambay area is here, this is fourth. And next is Sonata. See, Sonata, where Son, Narmada and Tapi river are there, so that is fifth. Right, then sixth is Godavari basin, this is Godavari basin, and seventh is Mahanadi basin, so this is Mahanadi. So these are the 7 geothermal provinces of India, and major is Puga Valley of Ladakh region. Ladakh region is very famous for geothermal. Right, so let's discuss that. Right, so these are the 7 geothermal provinces. The Puga Valley in Ladakh region is most promising geothermal field. Right, it is being used mainly for poultry farming, mushroom cultivation, and pashmina wool processing, all of which need higher temperature. So Puga Valley, we need to remember, Puga Valley in Ladakh is well known for geothermal power generation. Right, so Puga Valley in Ladakh, you need to remember. Right, very important. Right, these are the geothermal provinces. ये भी 7 you need to remember. Right, so that is the thing. Now let's see next is the most important, that is hydrogen energy. Right, hydrogen energy, and under this we will be studying green hydrogen. Right, which is very important since 2-3 years. Right, green hydrogen has become favorite topic of UPSC. Right, so that is, so hydrogen energy is a renewable energy. Right, so now let's see if we see hydrogen, that is H2. Right, so hydrogen is available in atmosphere. Right, in fact it is the most abundant material in the universe. जैसे सन में भी है हाइड्रोजन, राइट. सो हाइड्रोजन से हीलियम बनता है, तभी सन is generating heat, right? So hydrogen is the most abundant element on the atmosphere, right? In the universe, right? In universe, hydrogen is most abundant, right? So hydrogen can be used in energy generation. This hydrogen can be used in energy generation. However, क्या है, ठीक है, hydrogen is abundant in our environment, right? In fact, in our earth also hydrogen is present. Example, it is stored in water. ठीक है, वाटर में हाइड्रोजन है, H2O. H2O, H2 is what? Hydrogen, right? Then in hydrocarbons such as, जैसे मीथेन है, right? Methane has hydrogen, see, that is H2, right? CH4, there is H2. And other organic matter, जो भी plants है, जो भी animals है, right? जैसे इंसानों के अंदर भी हाइड्रोजन है, right? So and plants में भी other organic matter also has hydrogen. That means hydrogen is available. But हम हाइड्रोजन अवेलेबल है, बट हाइड्रोजन इज नॉट इन एलिमेंटल फॉर्म, राइट? ये कभी वाटर के फॉर्म में, कभी मीथेन के फॉर्म में, राइट? कभी कुछ और के फॉर्म में. सो फॉर दैट हाइड्रोजन को एनर्जी यूज करना है, फर्स्ट वी नीड टू गेट हाइड्रोजन फ्रॉम दीज एलिमेंट्स. इनसे पहले हाइड्रोजन को सेपरेट करना है, फिर उस हाइड्रोजन को यूज करेंगे, राइट? एज ए एनर्जी, राइट? सो लाइक देन however for its usage we need separate hydrogen है, उसको कैसे लाएंगे, that we see. Types of hydrogen depending upon the process of extraction. तो हाइड्रोजन को निकालने के लिए, राइट, हम अलग अलग तरीके यूज करते हैं. सो उनसे उनका नाम आता है, that is green hydrogen, blue hydrogen, gray hydrogen, etc. राइट? बाकी पिंक हाइड्रोजन, येलो हाइड्रोजन वगैरह है, देर आर नॉट दैट इंपॉर्टेंट. ठीक है, कभी जो सिर्फ कोचिंग इंस्टीट्यूट्स में, बिकॉज दे आर वेरी कंफ्यूजिंग, राइट? ये वो, राइट, वो बनाने के लिए बना. सो मोस्ट इंपॉर्टेंट आर ग्रीन हाइड्रोजन, ब्लू हाइड्रोजन एंड ग्रे हाइड्रोजन. ये तीनों याद करेंगे हम, राइट? सो फर्स्ट इज ग्रीन हाइड्रोजन, द मोस्ट इंपॉर्टेंट. अब ग्रीन हाइड्रोजन क्या है, राइट? ग्रीन हाइड्रोजन क्या है? बेसिकली हाइड्रोजन हमें चाहिए, राइट, एज ए एनर्जी. सो ग्रीन हाइड्रोजन इज hydrogen, right? Hydrogen produced through electrolysis of water using electricity from renewable sources. So let me explain you. See, hydrogen. So hydrogen हमें produce करना है. Hydrogen हम किससे कर रहे हैं? By using water, right? So by using water we will produce. So water is H2O, right? Now from H2O we need to get hydrogen, H2, right? We need hydrogen, H2, right? So उसके लिए क्या करेंगे? हाइड्रोजन, वाटर से we need to get hydrogen. For that what we do is we do electrolysis. That is, electrolysis is, so you can write it down. Electrolysis is splitting of water, that is H2O. Splitting of water H2O into H2 plus O2 by using electricity. Electricity is called electrolysis. So that is, see, water है, हम इसको एक उसमें एक सेल में डालेंगे, राइट? इन एक सेल, सी, सेल, राइट? सो लेट्स वॉच ए वीडियो, you will get clarity. Let's watch video first, small video, then we will be discussing it.
Electrolysis involves splitting water into hydrogen and oxygen with the help of electricity. When a direct current is passed through the water, oxygen appears at the positive anodes, while hydrogen is released from the negative cathodes. In terms of volume, exactly 2 times more hydrogen is produced than oxygen. As pure water is not a good conductor of electricity, something like salt is added, not a very environmentally sound method. If you use a proton exchange membrane, PEM for short, it's possible to extract hydrogen from pure water, as the membrane provides the necessary particle transport between anodes and cathodes.
Right? You have watched the video? See, right? So electrolysis is what? We are splitting water. So H2, see, this is 2H2O, right? We split into 2H2 plus O2, right? So here that is splitting. We split water into H2 plus O2. So here, right? In video also we have seen. So H2 and O2 by using electricity, that is called electrolysis. And जो electrolysis के लिए electricity we are using, that is from renewable sources. This is also important. वो renewable sources होगा तभी ये green hydrogen होगा, right? That means hydrogen without no release of carbon dioxide or other gases. So that is renewable. So renewable sources are solar. जो भी इलेक्ट्रोलाइसिस में इलेक्ट्रिसिटी यूज कर रहा है इस सेल में ब्रेक करने के लिए, that has to be from solar or wind, right, or other renewable sources. So that is called green hydrogen, right? So green hydrogen is hydrogen we have produced, right, produced through electrolysis of water. Water को electrolysis करके break down करके, right, जो hydrogen निकाला, separate किया, right, that is called green hydrogen with the use of renewable sources, right? So that is green hydrogen, right? So हो गया, समझ में आ गया green hydrogen. Then next let's see blue hydrogen, right? See, this equation also you can write, you will get clarity. So 2H2O, right, if we break down into H2 plus O2, right, so that is green hydrogen, right? Then next is blue hydrogen. Next is blue hydrogen, right? Blue hydrogen, that is derived from natural gas, through the process of steam methane reforming. So blue hydrogen is derived from natural gas. So natural gas, we have what? Natural gas में major component is methane, that is CH4, right? So methane through steam methane reforming. Let's see. Steam methane reforming mixes natural gas with very hot steam in the presence of catalyst. See, this is basically, you can write the equation, that is, see, CH4. Okay, see, let's write it here. See, CH4, that is methane, plus H2O, water, gives rise to CO plus 3H2, and again if we add water, right, with this, so then it will be CO2 plus 4H2. So this is called hydrogen, that is blue hydrogen. So we are getting hydrogen from methane, right? Hydrogen from methane or natural gas. So when steam methane reforming, that is mixes natural gas with a very hot steam. Hot steam is what? Steam is H2O. So this is steam, right? Water in the form of steam. When we mix it with methane, right? Methane or natural gas, right? Natural gas में component is methane, right? So natural gas plus steam, right? When we mix in the presence of a catalyst, so catalyst भी कुछ ना कुछ होगा, right? So where the chemical reaction creates hydrogen and carbon monoxide. So ये hydrogen है, so this also we can use, right? So this is also blue hydrogen, right? But carbon monoxide avoid करने के लिए हम और water add करें, so that would be CO2 plus 4H2. So that is blue hydrogen, right? So this is the blue hydrogen, right? So steam methane reforming. So steam and methane we are mixing, that is called steam methane reforming, will create blue hydrogen, right? Next is gray hydrogen. That is hydrogen derived using fossil fuel is called gray hydrogen. जैसे मान ले इधर है in electrolysis, right, to इलेक्ट्रिसिटी जनरेशन के लिए हम रिन्यूएबल की जगह हम फॉसिल फ्यूल्स यूज किया, राइट? जैसे कोल यूज किया, इधर वाटर को गर्म करने के लिए इलेक्ट्रिसिटी, राइट, स्प्लिट करने के लिए इलेक्ट्रोलाइसिस ऑफ वाटर यूजिंग इलेक्ट्रिसिटी. इफ वी यूज फॉसिल फ्यूल्स, दैट इज कॉल्ड ग्रे हाइड्रोजन, gray hydrogen, right? And here also इधर भी हम अगर CO2 एलो किया, राइट, अगर CO2 को कैप्चर किया दैट वुड बी ब्लू हाइड्रोजन, अगर CO2 को एटमॉस्फेयर में रिलीज किया सो दैट वुड बी अगेन फॉसिल फ्यूल रिलीज हो रहा है सो दैट वुड बी कॉल्ड ग्रे हाइड्रोजन, राइट? और मोस्टली हाइड्रोजन डिराइव्ड यूजिंग fossil fuels is called gray hydrogen. Fossil fuels is called gray hydrogen. Whether we are using coal, right? We are using natural gas. Natural gas में CO2 leak करेंगे, so that would be gray hydrogen, right? So these are the types of hydrogen we need to remember, right? So now we have understood. Now let's see other things. See, globally, hydrogen is being produced mostly from fossil fuels, right? 76 from natural gas, right? Natural gas is again a fossil fuel, right? And around 23% from coal, with remaining from electrolysis of water. Electrolysis of water से अभी just 1% of hydrogen is made, right? 1% of hydrogen is made. So in India, hydrogen is being commercially produced in fertilizer industry, petroleum refining, and chemical industry, and also as a byproduct of chlor-alkali industry. See, these things we need to remember. So currently fertilizer industry, we are producing hydrogen. Petroleum refining, we are producing hydrogen. Chemical industries are producing, and also as a byproduct of chlor-alkali industries, hydrogen is being produced in India, right? Now are the applications of hydrogen, right? Applications, we can use hydrogen as a fuel, right? We can use hydrogen to make chemicals, right? That we will be studying, and we can also use it as hydrogen enriched CNG, right? So let's study about applications of hydrogen, that is hydrogen fuel cells. First is hydrogen fuel cells, right? Hydrogen fuel cells, right? So hydrogen fuel cell systems are used for generating electricity. They are used for generating electricity in vehicular applications, right? Fuel cell cars, buses, right? Or anything we can use, right? Hydrogen fuel cells, ठीक है, जो cars में भी है we'll use hydrogen fuel cells, that also will be studied, right? Then hydrogen fuel cells and portable devices, laptops or phones, right? In laptops and phones also, that is hydrogen fuel cells can be used in big cars, buses, right? And small devices also we can use. So now let's see a video. You will get clarity on hydrogen fuel cells, right? How they work, right?
Let's learn how a hydrogen fuel cell works. Do you know how a battery works? Yes, the fuel cells work like batteries, but they do not run down or need recharging. They can produce electricity constantly. Fuel cells can operate at higher efficiencies than a combustion engines and can convert the chemical energy in the fuel to electrical energy. A fuel cell is composed of two plates separated by an electrolyte membrane. One plate is called anode and the other is cathode. Hydrogen is passed through the anode while oxygen is passed through the cathode. At the anode, the hydrogen molecules are split into electrons and protons by a catalyst. The positive particle of hydrogen can pass through the membrane, but the negative particle cannot pass through it. However, atoms need an equalizing charge, and to achieve this, electron must change the path. That time, the electrons are forced through a circuit and generates electric current and heat. The end product of this reaction is water, H2O. At the cathode, the hydrogen protons, electrons, and oxygen combine to produce water molecules. Due to the lack of moving parts, the cells are highly reliable and its operation is silent. The hydrogen fuel cell is useful in the automobile industry also. Currently, there are several companies around the world working on the development of hydrogen cars.
Right? You have watched the video, right? There, how hydrogen fuel cells are working, right? So they have anode and the cathode, right? So it's basically, see, there is anode and there is cathode. and through anode we release H2, right? And anode में O2, right? And H2, and there is membrane, right? There is membrane, and H2 में we try to break down hydrogen. Hydrogen has both positive and negative charges, right? So these positive charges go through the membrane and go here, right? And then negative charges, they try to move and they generate electricity, right? You have watched the video, you have understood, right? So that's why I incorporated video where you can virtually understand things, right? So a fuel cell is a device that generates electricity by chemical reaction. Yes, chemical reaction, chemicals react कर रहे हैं, so इधर से electron से generate electricity. An electrolyte membrane, right? Electrolyte membrane carries electrically charged particles from one electrode to another. So membrane से positive charged वाला उधर जा रहा है, right? Anode to cathode, as well as uses catalysts to speed up the reactions and produce electricity at electrodes. So electricity at electrodes produce होगा, right? And uses of क्या fuel cells, that is eliminates pollution as only water vapor and heat are emissions from fuel cells. So कुछ CO2 CO कुछ एलिमिनेट नहीं, कुछ बाहर नहीं निकलेगा, राइट? जैसे हाइड्रोजन फ्यूल कार से, राइट, देयर ओनली वाटर वेपर वुड बी द वेस्ट, सिर्फ पानी ही आएगा या थोड़ा गर्म हवा आएगा, राइट? उसके अलावा कोई केमिकल्स नहीं निकलेगा. सो दैट्स व्हाई ग्रीन फ्यूल कार्स, राइट, आर ये very good for pollution reduction, right? So eliminates pollution, right? Eliminates, completely eliminate करती है, because पानी और हीट दोनों ही आउटकम आते हैं और कुछ नहीं आता, राइट? सो डू नॉट नीड पीरियोडिकली रिचार्जिंग लाइक बैटरीज. जैसे ईवी में बैटरीज नीड पीरियोडिकल रिचार्जिंग, राइट? एंड प्रोड्यूस इलेक्ट्रिसिटी एज लॉन्ग एज सप्लाइड विथ हाइड्रोजन एंड ऑक्सीजन. ऑक्सीजन तो एयर में मिलेगा, राइट? बस हाइड्रोजन प्रोड्यूस करना है. सो हाइड्रोजन हम ग्रीन हाइड्रोजन या अदर टाइप ऑफ हाइड्रोजन प्रोड्यूस करके दे देंगे, राइट? सो एज लॉन्ग एज ऑक्सीजन इज देयर, हाइड्रोजन का सप्लाई होगा, तो जैसे हाइड्रोजन सप्लाई पेट्रोल पंप्स में वी कैन इजीली फिल इट, राइट? देन हायर इलेक्ट्रिकल एफिशिएंसी, देन नॉइज फ्री ऑपरेशंस, राइट? देयर इज नो नॉइज इन द हाइड्रोजन व्हीकल. जैसे इलेक्ट्रिकल व्हीकल्स में भी द नॉइज इज नॉट देयर, राइट? सो नॉइज फ्री. देन लिमिटेशंस आर high cost of catalysts like platinum etc we need to use in hydrogen vehicles, right? So that is cost. Then high cost of equipment, issues with respect to storage of hydrogen gas, how much you need to store, right? Where you will be storing in the car, right? Then maintenance issues like corrosion etc, right? So hydrogen fuel cells basically जो hydrogen based cars है, right, there we will be using hydrogen fuel cells technology only, right? So these are the positives and the negatives, right? So in hydrogen cars also if we use green hydrogen, right, तो उसमें अभी जो डीजल कार्स है, राइट, पोल्यूटेंट्स लाइक कार्बन डाइऑक्साइड, कार्बन मोनोऑक्साइड, नाइट्रस ऑक्साइड एक्सेट्रा रिलीज होगा, राइट? ग्रीन हाउस गैसेस एक्सेट्रा. अब हाइड्रोजन फ्यूल सेल्स में वो सब कुछ नहीं रिलीज होगा, राइट? रेदर सिर्फ पानी एंड गर्म हवा ही रिलीज होगा, राइट? सो दैट इज द थिंग. नेक्स्ट इज एप्लीकेशन ऑफ हाइड्रोजन इज हाइड्रोजन एनरिच्ड सीएनजी, राइट? हाइड्रोजन एनरिच्ड सीएनजी, जो सीएनजी गैस है, राइट? जैसे दिल्ली में बसेस आर यूजिंग सीएनजी, एंड इन दिस सीएनजी वी कैन मिक्स हाइड्रोजन, मेकिंग इट मोर एफिशिएंट एंड मेकिंग इट लेस पोल्यूशन, राइट? लेस पोल्यूशन रिलीज होगा बसेस से, राइट? सो हाइड्रोजन कैन बी यूज्ड एज एन एनर्जी कैरियर डायरेक्टली इन इंटरनल कंबशन इंजन्स एंड टर्बाइन्स इन प्लेस ऑफ फॉसिल फ्यूल्स और ब्लेंडेड मिक्सचर. सो या तो ये डायरेक्टली भी यूज कर सकते हैं, राइट? हाइड्रोजन एज ए फ्यूल, जो हाइड्रोजन व्हीकल्स है उसमें डायरेक्टली कैन बी यूज एनर्जी कैरियर डायरेक्टली इन इंटरनल कंबशन इंजन्स एंड टर्बाइन्स इन प्लेस ऑफ फॉसिल फ्यूल्स और ब्लेंडेड मिक्सचर विथ फॉसिल फ्यूल्स. सो हियर वी आर ब्लेंडिंग, राइट? या तो डायरेक्टली यूज करो जो हाइड्रोजन व्हीकल्स में, या ब्लेंडेड करके यूज करो. सो HCNG is a blend of hydrogen and CNG. The ideal hydrogen concentration is 18%. So 18% would be, right? Yeah, and the rest 82% would be CNG. So 18% is hydrogen and the rest is CNG. So blend करना है, right? So CNG is a compressed natural gas, right? So a natural gas mainly composed of methane, that is CH4, right? Right? So CNG emits less air pollutants, right? If we compare with petrol and diesel vehicles, so it emits less air pollutants like CO2, carbon monoxide, nitrogen oxides, and particulate matter than petrol or diesel. Right? So CNG वो करती है when we mix it with hydrogen, it further reduces. So benefits of HCNG, right? Compared to conventional CNG, right? Use of HCNG can reduce emission of carbon monoxide up to 70%. So जो carbon monoxide है, right? This carbon monoxide जो CNG में निकलती है उससे 70% रिडक्शन कर सकता है, right? Important point. Then safer than hydrogen due to its lower energy content. ठीक है, safer than hydrogen because of lower energy content of HCNG. Then यूजेबल विथ एग्जिस्टिंग सीएनजी इंफ्रास्ट्रक्चर, कुछ और चेंज करने की जरूरत ही नहीं है, बस हाइड्रोजन ब्लेंड करो, राइट? यू कैन यूज इट विथ एग्जिस्टिंग सीएनजी इंफेक्टर, नो मेजर इंजन मॉडिफिकेशंस आर रिक्वायर्ड, राइट? देन इंप्रूव्स इंजन एफिशिएंसी भी बढ़ाएगी, राइट? सो नो मेजर मॉडिफिकेशंस आर रिक्वायर्ड, एग्जिस्टिंग इंफ्रास्ट्रक्चर से कर सकता है, कार्बन मोनोऑक्साइड का पोल्यूशन 70% कम करेगी. देन चैलेंजेस इज डिटरमाइनिंग ऑप्टिमाइज्ड हाइड्रोजन नेचुरल गैस मिक्स रेशियो, then lack of storage and supply infrastructure, then more expensive than CNG. Lack of storage and supply infrastructure, then more expensive than CNG, right? ये more expensive है HCNG because hydrogen produce करना ही मुश्किल है, right? Hydrogen मिलाना फिर वो expensive हो जाएगा, right? Then the third application, right? Third application is hydrogen is used as a raw material in fertilizer, chemical and petroleum refining industries as it is fundamental building block to manufacture of ammonia, right? So third application is manufacturing of ammonia में hydrogen use हो रहा है, right? That is the third application, right? So second application is hydrogen enriched fuel, so hydrogen fuel cells, right? So next is, now let's see a question. See, this is question asked in UPSC 2019, right? That is on HCNG. So HCNG, that time it was in current affairs, right? So it was in current affairs and magazines and all are covered, bro. So that's why this question is there. Let's understand it. See, in the context of proposals to use of hydrogen enriched CNG as a fuel for buses in public transport, right? In buses of Delhi, HCNG was used, right? Consider the following statement. The main advantage of use of HCNG is the elimination of carbon monoxide emissions. अब देखो, elimination means 100% elimination of carbon monoxide, but ये eliminate नहीं करती, ये 70% reduction करती है, right? So this is incorrect. So 70% reduction. So one is incorrect. So option 1 is incorrect. So this option is eliminated and this option is eliminated, right? So now either 2, 3 are correct and or 4 is correct. So HCNG as fuel reduces carbon dioxide and hydrocarbon emissions. Yes, it is correct. So it reduces, भाई थोड़ा कम तो करती है CO2 and hydrocarbon emissions भी, and hydrogen up to 1/5 by volume, that is 100 by 5, that is 20% by volume can be blended with CNG as a fuel for buses. Yes, 18% best है, right? So up to 1/5 can be blended. Yes, it is correct. HCNG makes the fuel less expensive than CNG. No, hydrogen है भाई, वो बनाने में टाइम वो लगेगा पैसा, so it is more expensive. So fourth is incorrect. So option 2 and 3 are correct, right? So now let's see HCNG we have, that is hydrogen enriched CNG is a blend of hydrogen and CNG, the ideal hydrogen concentration being 18%. Ideal hydrogen concentration being 18%, hence statement 3 is correct, right? So compared to conventional CNG, use of HCNG can reduce emission of carbon monoxide up to 70% and 15% reduction in, so carbon monoxide up to 70% and 15% reduction in total hydrocarbon emissions. So hence statement 2 is incorrect as HCNG cannot eliminate carbon monoxide emissions. Statement 2 is correct as HCNG reduces carbon dioxide and hydrocarbon emissions, right? Statement 4 is incorrect as HCNG is more expensive than CNG, right? So that is the thing. Now let's see next question. So this is question asked in UPSC 2023. UPSC 2023, that is with reference to green hydrogen. Consider the following statements, right? So it can be used directly as a fuel for internal combustion. Yes, see, we have studied it can be directly used or it can be used as a mixture, right? So see here, can be used as an energy carrier directly in the internal combustion engines and turbines in place of fossil fuels. By hydrogen vehicles में हम क्या कर रहे हैं? Directly we are using it, right? Directly we are using it. So it can be used directly as a fuel for internal combustion. Yes, right? Petrol की जगह, diesel की जगह we can directly use green hydrogen. Yes, we can use it, right? It can be blended with natural gas and used as a fuel for heat or power generation. वो भी देखा भाई, it can be, that is HCNG, right? HCNG is hydrogen compressed natural gas blending. So it can be blended with natural gas and used as a fuel for heat or power generation. It can be used in hydrogen fuel cells to run vehicles. Yes, right? So all three are correct. So green hydrogen can be used as in the hydrogen fuel cells to run vehicles. So all three are correct, right? So green hydrogen is very important. So अब देखो 2023 में question, right? So now let's see explanation. See, green hydrogen is a hydrogen produced through electrolysis of water using electricity from renewable energy. So green hydrogen is electrolysis, water से H2O को हमने electrolysis से break किया H2 plus O2 में, right? By using electricity of renewable energy. So that is green hydrogen. So green hydrogen. So hydrogen is a colorless, odorless, tasteless, non-toxic and highly combustible gaseous substance. Highly combustible, right? So it is the lightest, simplest and most abundant element in the universe, right? Green hydrogen is hydrogen produced through electrolysis of water, and for electrolysis of water we use renewable energy sources like solar, wind or hydro, right? So green hydrogen can be used directly as a fuel for internal combustion by a hydrogen engine. Can be used directly as a fuel for internal combustion of hydrogen engine. Hydrogen engines burn hydrogen in an internal combustion engine in just the same way gasoline is used in the engine, right? Hydrogen vehicle, basically in place of petrol or diesel we are just using hydrogen, right? Directly used. Green hydrogen can be blended with natural gas to create a mixed fuel. This blend is used for heating or power generation. Example is HCNG, right? Then green hydrogen is ideal for hydrogen fuel cells, yes, which convert chemical energy of hydrogen into electricity, right? Powering vehicles, right? Basically hydrogen vehicles में hydrogen fuel cells ही use कर रहा है, right? So that is the thing. Now let's see, आगे देखो 2023 में second question on green hydrogen, right? Why it is asked? Because in that year National Green Hydrogen Machine is launched. National Green Hydrogen Mission is launched in 2013, right? So that's why two questions are there, right? So see, consider the following heavy industries: fertilizer industry, oil refinery, steel plant. Green hydrogen is expected to play a significant role in decarbonizing how many of the above industries? See, decarbonizing means reducing CO2 emissions, right? Green hydrogen can reduce CO2 emissions in how many of the above industries, right? See, we'll be studying green hydrogen machine towards the end of the course, right? So I have already made notes, right? So here we haven't discussed green hydrogen machine, right? Towards the end we will be discussing अब green hydrogen machine में ये सब चीजें मेंशन किया हुआ, right? क्या क्या इंडस्ट्रीज को decarbonize करेंगे उससे, right? All these things are mentioned, right? So this was there in news that year, right? It is a very easy question. Basically सारे इंडस्ट्रीज को decarbonize करते हैं, वो कैसे देखते हैं, right? Here we broadly see, right? But we'll understand in later class also, right? See, first is answer C. Answer C is the answer. So that is fertilizer plants primarily use hydrogen to produce ammonia, right? So first fertilizer plant से, right, वो hydrogen use करता है to produce ammonia. Traditional ammonia production relies on natural gas to produce hydrogen, resulting in high carbon emissions. So natural gas से produce hydrogen, अगर green hydrogen use किया by renewable energy use कर रहा है, right? Hydrolysis of water use कर रहा है, so that will reduce carbon emissions, right? So green hydrogen produced through electrolysis using renewable energy can be used to produce hydrogen rich fertilizers, drastically reducing carbon emissions, right? नहीं तो पहले क्या यूज कर रहे थे, natural gas to produce hydrogen which release carbon, right? Option 1 is correct. Then oil refineries use hydrogen in various processes including hydrocracking and desulfurization. The hydrogen used in these processes is often produced from fossil fuels, leading to substantial carbon emissions. From fossil fuels, leading to substantial carbon emissions. Right? So, by using green hydrogen, by using green hydrogen, oil refineries can significantly reduce their carbon footprint. Right? Then similarly, steel industry is responsible for significant amount of global carbon emission. Green hydrogen can be used as a reducing agent in steel making process, replacing coal or coke, right? This process known as direct reduction enables the production of green or lower carbon steel, right? Additionally, green hydrogen can be used in the steel industry for heat generation, right? Instead of coal, right? And electricity production, further reducing carbon emissions, right? Basically, green hydrogen has power to transform, right, or reduce carbon emissions in most of the industries, right? So now let's see next. See again, अब देखो क्वेश्चन आया 2024 में, right? Which one of the following is exhaust pipe emission from fuel cell electric vehicles? Fuel cell electric vehicles, right? Fuel cell technology में waste क्या होगा? Powered by hydrogen. Hydrogen से powered, right? Electric vehicle से उसमें exhaust waste क्या आएगा? That is water vapor. So fuel cell, right? Fuel cell we have studied, waste is what? Just water vapor and heat, right? So water vapor is the answer, right? Let's see. Fuel cell electric vehicles powered by hydrogen are more efficient than conventional internal combustion engine vehicles and produce no harmful tap line emissions as they only emit water vapor and warm air. So water vapor is what? Water, right? जो भी जैसे ग्रीन हाइड्रोजन कार्स हमने यूज किया, राइट, उसमें बस कुछ पोल्यूटेंस ही नहीं आएगा पाइप से, राइट, राइट, ओनली वाटर वेपर ही आएगा और गर्म हवा आएगा, राइट, दैट्स इट. सो दैट मीन्स दे आर वेरी environment friendly, right? So hydrogen is environment friendly and fuel cells technology itself is environment friendly, right? So now let's see. अब देखो 2015 में same question आया, right? So with reference to fuel cells in which hydrogen rich fuel and oxygen are used to generate electricity. अब देखो fuel cell electric vehicles, a fuel cell, right? Fuel cell in which hydrogen rich fuel and oxygen are used to generate electricity. Consider the following statements, right? So that is, if pure hydrogen is used as a fuel, the fuel cells emit heat and water as byproduct. अब देखो सीधा ये point is the answer. Is water vapor is what? Water, right? क्या आएगा? Water आएगा. So अब अगर ये क्वेश्चन अच्छे से कर लिया होता तो 2024 question you would have easily attempted, right? So that's why PYQs are very important and that's why I am focusing mostly on PYQs also in the course, right? So this is correct. So if pure hydrogen is used as a fuel in fuel cell, right, the fuel cells emit heat and water as byproduct. Yes, that is only these two. Then fuel cells can be used for powering buildings and not for small devices like laptop computers. No, we checked fuel cells can be used for small devices also, laptop, phone, right? उसमें भी hydrogen fuel cells use कर सकते हैं, right? Then fuel cells produce electricity in the form of alternating current, right? Fuel cells, no, they produce direct current, right? जैसे electron से directly current आ रहा है, right? We have seen the video in video also, right? So जब hydrogen, right, oxygen, hydrogen positive charges इधर move होती है, so negative charges they move in the electrode, so they generate direct electricity, not alternating electricity, right? So which of the following statements? That is one only. Option A is the answer. That is C. Let's check about fuel cell technology. See, a fuel cell is an electrochemical cell that converts chemical energy of fuel, often hydrogen, and an oxidizing agent, often oxygen, into electricity through a pair of redox reactions. Pair of redox reactions, right? Fuel cells are different from batteries, as in batteries, the chemical energy usually comes from substances that are already present in the battery, whereas in fuel cells, electricity is continuously produced only as long as fuel and oxygen are supplied, right? Only as long as fuel is hydrogen and oxygen are supplied, right? जैसे green hydrogen cars में fuel hydrogen green hydrogen होना चाहिए, right? If pure hydrogen is used as a fuel cells emit only heat and water as byproduct, hence statement 1 is correct. Fuel cells could power our cars with hydrogen replacing petroleum fuels, right? The fuel cells can power almost any portable device or machine that uses battery, right? सो कुछ भी बैटरी यूज करती है तो उसको कर सकती है, राइट? जैसे लैपटॉप, कंप्यूटर्स, सेल फोन्स, हियरिंग एड्स, राइट? हेवी व्हीकल्स, राइट? जैसे लॉरी, बसेस एक्सेट्रा, उनको भी कर सकती है, कुड बी पावर्ड बाय फ्यूल सेल्स, राइट? दैट स्टेटमेंट 2 इज इनकरेक्ट. हाइड्रोजन पावर्ड फ्यूल सेल्स आर मोर एनर्जी एफिशिएंट देन ट्रेडिशनल कंबशन टेक्नोलॉजी. मोर एनर्जी एफिशिएंट than traditional combustion technologies. Fuel cells produce electricity in the form of direct current. So ये भी important. So हमने solar panels भी देखा, right? That also produce direct current, and the hydrogen fuel cells, right? They also produce direct current. So this is also very important point you need to remember, right? So with this we are done with green hydrogen fuel cells, etc., right? So now let's deal with biofuels, again an important topic. Biofuel, see, again very important topic, right? See, biofuel is a type of fuel that is generated naturally or artificially from the biomass of a plant or algae material or animal waste. ठीक है? See, any fuel that is generated artificially or naturally from biomass of a plant, algae material and animal waste is called biofuel, right? It is considered a renewable energy because renewable source because the feedstock material कैन बी रिप्लेनिश्ड इजीली. जैसे जो भी मान ले प्लांट्स यूज किया, राइट, बायोफ्यूल बनाने के लिए, ठीक है, उनको दोबारा प्लांट ग्रो कर सकते हैं. algae material यूज किया, वी कैन ग्रो इट, राइट? सो एनिमल वेस्ट यूज किया, सो एनिमल वेस्ट वी कैन जनरेट इट. सो दैट्स व्हाई इट इज कॉल्ड ए renewable energy, right? So with the rising crude oil prices, biofuels are seen as a sustainable alternative to be used mainly as a blending, right? Most of the biofuels we can use as blending with petroleum. जैसे petroleum में biofuel मिलाया, so we can reduce the use of petroleum, right? Based fossil fuels. India has set targets of 20% ethanol. See, ethanol is a biofuel, right? We will be studying it. So 20% ethanol blending in petrol. So that means 20% कम पेट्रोल यूज करेंगे, राइट? सो बायोफ्यूल, राइट? 5% biodiesel blending. So biodiesel is a biofuel, right? So biodiesel in diesel में 5% biodiesel मिलाएंगे, right? So by 2030 under national policy on biofuels. So national policy on biofuels also important, we will be studying, right? So national policy on biofuels, we have target of 20% ethanol blending and 5% biodiesel blending by 2030, राइट? वो 2022 में चेंज करके 2025 तक लाया, राइट? दैट वी विल बी स्टडी, राइट? सो दैट इज बायोफ्यूल इज एनी फ्यूल वी आर मेकिंग विथ प्लांट वेस्ट, algae material or animal waste, that is called biofuel, right? Let's see based on feedback or raw material which we used to produce biofuels, they are classified into four generation of biofuels, right? So that is first generation biofuels are called biofuels generated with the use of food crops, right? Right? So biofuels generated with the use of food crops like wheat. See, wheat is a food crop, sugarcane is a food crop, right? We make good with sugarcane, so sugarcane is a food crop. corn, soybean, etc. Right? These come under first generation biofuels. जहाँ food crops का waste वगैरह use करके if we make biofuel, that is called first generation biofuel. And the issue with first generation biofuels is why we are using food biomass, right? Food crops biomass. So it would lead to debate of food versus fuel, right? Because food का जो material है we are using it for fuel, right? और food का जो land cultivation है, right? That will be shifting it to fuel biofuel cultivation, right? Because these plants we need to cultivate, right? To use their biomass. So this will lead to food versus fuel debate. So then comes the second generation biofuel to overcome first generation limitations, right? That is food versus fuel debate overcome करने के लिए. So biofuels generated with the use of non-food crops, right? That is non-food crops like jatropha, wood, grass, etc. come under second generation biofuels. अब इसमें क्या हुआ? Non-food crops तो use कर रहा है, but land used for cultivation of other crops is used for fuel, right? So that is the limitation. Then उसको वो करने के लिए third generation biofuels are biofuels generated with the use of algae, that is macroalgae, microalgae come under third generation biofuels. So biofuels generated with the use of algae come under third generation. Algae use करके biofuels बनाया तो they are third generation biofuels. Then next is fourth generation biofuels, that is biofuels generated using genetically engineered organisms, right? Genetically engineered organisms are called fourth generation biofuels, that is genetically modified algae and cyanobacteria, where algae can grow quickly, right? Cyanobacteria can grow quickly, right? They are called genetically modified organisms. They are called main organisms used in production of biofuels or fourth generation biofuels में genetically modified algae or other organisms use कर रहे हैं तो that is called fourth generation biofuels, right? Then different types of biofuels, right? Different. See, first is bioethanol. See, bioethanol is an alcohol, right? Alcohol generated through fermentation of plant materials. Plant materials को fermentation करेंगे, right? जैसे दारू बनता है, right? So bioethanol is also type of alcohol, right? Formed by fermentation. See, most of the alcohol is fermentation of rice, fermentation of potatoes, right? So usse alcohol is made. So bioethanol is an alcohol generated through fermentation of plant materials like corn, sugarcane, etc. Right? So that is bioethanol. So and bioethanol is mainly used as blending agent with petrol, right? जैसे biofuel policy में 20% blending target है, right? So mainly petrol से blend करते हैं, right? To increase octane and cut down carbon monoxide and other harmful minerals. So जैसे that is the another use of biofuels. Biofuels they cut down pollutants also, right? Along with पेट्रोल का कम यूसेज होगा, फिर पोल्यूटेंट्स को भी कट डाउन करेगा एंड एफिशिएंसी हाई ऑक्टेन भी है एंड कट डाउन कार्बन मोनोऑक्साइड एंड अदर हार्मफुल एमिशंस, राइट? देन आता है बायोडीजल. बायोडीजल इज ए लिक्विड फ्यूल प्रोड्यूस्ड फ्रॉम वेजिटेबल ऑयल्स एंड एनिमल फैट्स थ्रू ट्रांसएस्टरिफिकेशन, राइट? थ्रू ट्रांसएस्टरिफिकेशन से सो बायोडीजल इज ब्लेंडेड विथ डीजल, राइट? Then आता है biogas, right? So biogas primarily a mixture of methane and other gases like CO2 and N2 produced by anaerobic digestion of organic matter such as food or animal waste. See, if we see with cow dung, right, we can generate biogas that is mostly methane, right? Anaerobic जहाँ oxygen नहीं है तो where if we put animal waste, right, or food waste, that will generate methane, right? Methane or biogas, right? Biogas is combination of methane, CO2 and other gases, right? So biogas also we can use it generate. Then biojet fuel, it is a type of biofuel which is produced from biomass resources and used in place or blended with air turbine fuel, right? So sustainable air turbine fuel, that also will say biojet fuel is biofuel, right? So ये या तो ब्लेंड कर सकते हैं या इन प्लेस ऑफ टर्बाइन फ्यूल, एयर टर्बाइन फ्यूल एरोप्लेन्स में यूज कर सकते हैं, राइट? सो Now let's see national policy on biofuels 2018, again very important, right? National policy on biofuels 2018. So aim of the policy is to increase use of biofuels in energy and transportation sectors of the country, right? And to utilize, develop and promote domestic feedstock and its utilization for production of biofuels. So domestic feedstock, जो भी biofuels produce करने के लिए हमें बायो वो चाहिए, right? By see what we need, see this is biomass, right? Biomass चाहिए, right? जैसे plants का, right? Animal waste और algae, right? So domestic उसको भी biomass production के लिए वो encourage करना, right? That is the main goal, right? Then implementation by National Biofuel Coordination Committee, National Biofuel Coordination Committee set up in 2020, chaired by Minister of Petroleum and Natural Gas, chaired by Minister of Petroleum and Natural Gas. It has representative from 14 other ministries and departments to take decisions for effective implementation of monitoring of biofuel program in the country, right? Provide overall coordination among FCI and oil marketing countries. FCI because we will be looking, right? Because कुछ food materials वगैरह है, right? वो भी we will be using as biomass, right? So that is there. So this is implementing agencies, National Biofuel Coordination Committee, headed by Minister of Petroleum and Natural Gas. Important point. Then one important point of the national policy on biofuels is it expanded the scope of raw materials which can be used as biomass, right? So it expanded the scope of raw materials used for ethanol production, right? Ethanol production, ethanol we produce and we will be blending it with petrol, right? अब ethanol production कहाँ का किन किन से बना सकता है, right? उसका scope बढ़ा दिया इसमें. So that is expanded the scope of raw materials. So that is by allowing use of sugarcane juice, right? That means food crops, right? Sugarcane is a food, right? We use good, right? So use of बोला use of sugarcane juice use कर सकते हैं ethanol produce करने के लिए. Then sugar containing materials like sugar beet and sweet sorghum, right? We can use, right, for ethanol production. Then starch containing materials like corn भी use कर सकते हैं for ethanol production. Then cassava you can use. Then damaged food grains like wheat, broken rice, rotten potatoes, unfit for human consumption can be used for ethanol production. Again, very important. Everything you need to remember. क्या क्या use कर सकते हैं? Sugarcane juice, sugar beet, sweet sorghum, corn, cassava, damaged food grains like wheat, broken rice, rotten potatoes, etc. can be used for ethanol production. There was a question, right? 2020 में there is a question on this, right? Then it also allows for surplus food grains for production of ethanol. So surplus food grains जैसे मान ले food FCI में surplus food grains है. These surplus food grains can be used for the production of ethanol, right? For blending with petrol to ensure appropriate price to farmers during surplus, right? उससे क्या होगा? फार्मर को अगर सरप्लस हुआ तो फार्मर को अच्छा प्राइस होगा बिकॉज इथेनॉल प्रोडक्शन के लिए एक्वायर करेंगे, राइट? हाउएवर इट नीड्स द अप्रूवल ऑफ नेशनल बायोफ्यूल कोऑर्डिनेशन कमिटी हेडेड बाय मिनिस्टर ऑफ पेट्रोलियम एंड नेचुरल गैस. सो इट नीड्स, अगर सरप्लस फूड ग्रेन्स को यूज करना है, इट नीड्स अप्रूवल ऑफ नेशनल बायोफ्यूल कोऑर्डिनेशन कमिटी हेडेड बाय मिनिस्टर ऑफ पेट्रोलियम एंड नेचुरल गैस, राइट? तो सरप्लस फूड ग्रेन्स यूज कर सकता है विद द अप्रूवल ऑफ नेशनल बायोफ्यूल कोऑर्डिनेशन कमिटी, राइट? देन इट encourages setting up of supply chain mechanisms for biodiesel production from non-edible oil seeds, used cooking oil and short gestation crops. Again ये भी important है. So used cooking oil can be used for biodiesel production. Biodiesel production because see biodiesel production esterification of oil and animal fat से biodiesel बनेगा. So उसके लिए used cooking oil, short gestation crops and non edible crops can be used, right? So then categorization of biofuels into 3 generations. Right, we studied 4 generation biofuels, right? So इस policy में 3 generations ही categorize किया, and support must be given to production of second generation ethanol, that is non-food crops. Second generation, that is non-food crop, food crop से biorefineries through viability gap funding. So viability gap funding से second generation ethanol production पे वो किया, right, promotion करने के लिए. Then policy was amended in 2022 and introduced target of 20% ethanol blending in India by 2025 from, so earlier 2030 थी, so अभी the 20% blending, ethanol blending in India by 2025-26. Right, then production of biofuels under Make in India program in special economic zones and export oriented units. Right, so production of biofuels, right, then to grant permission for export of biofuels in specific cases. So export of biofuels is also allowed under specific cases, right? So that is the thing. Now let's study about, so again very important, so you need to remember everything under national policy on biofuels, right? So now let's study the global biofuel alliance. Global biofuel alliance, that is to foster global cooperation for advancement and widespread adoption of biofuels, right? Global biofuel, and it was launched by India, so that's why it is important. Launched by India, right, at 2023 G20 summit. So this makes it very important. Global Biofuel Alliance, GBA, right? India at 2023 G20 summit. So members are 7, 4, 8, 12, right? So that is 7 G20 countries, right? Argentina, Brazil, Canada, India, Italy, South Africa, and USA. Then 4 G20 invitee countries, right? Here it is not mentioned, you can note it down, that is 4 G20 invitee countries, right? These are not part of G20, but they are invitee of G20: Bangladesh, Singapore, Mauritius, UAE, and 8 non G20 countries, right? Iceland, Kenya, Guyana, etc., right? Then 12 international organizations, right? There are many organizations, right? No need to remember, you just need to remember कि international organizations भी है. G7, all G20 members are not there, right? And 7 G20 members है, 4, basically you need to remember this कि countries भी इतना important नहीं है, कौन कौन सा countries है, right? So you need to remember these things, and if you can remember, by India is है because launched by India only, right? So that you can remember, and USA is also there, right? Brazil is there, right? Brazil is one of the important role in biofuels, right? Like that you can remember. Now let's see question C. This is question asked in 2020, right? According to India's national policy on biofuels, which of the following can be used as raw material for production of biofuels, right? According to India's which of the following can be used as raw materials for the production of biofuels? See, cassava is there, damaged wheat grains is there, groundnut seeds, hot grams not there, rotten potatoes, sugar beet is there. Sorry. So this is 1, 2, 5, 6 only, right? So let's see. We have already discussed national policy on biofuels, expanded the scope of raw materials, use of ethanol production by allowing use of sugarcane juice, sugar containing materials like sugar beet, sweet sorghum, starch containing materials like corn, cassava, damaged food grains like wheat, broken rice, rotten potatoes unfit for human consumption, etc. can be used as raw materials for production of biofuels, right? Now let's see next. See, this is question asked in 2017, that is, it is possible to produce algae based biofuels, okay? But what is are likely limitations of developing countries in promoting these industries? So developing countries में क्या limitations है in promoting the industries which produce algae based biofuels, right? In promoting this industry, production of algae based biofuels is possible in seas only and not on continents, no, right? So algae कहीं भी production कर सकता है based biofuels, right? Production of algae based biofuels is possible only in seas, no, and not on continents, no, right? So we can produce it anywhere, right? then 1 is incorrect. So here, right? Then 2, 3 is correct. Right? Economically viable production necessitates the setting up of large scale facilities which may raise ecological and social concerns. Then setting up and engineering the algae based biofuels production requires high level of expertise and technology until the construction is complete. Yes, right? We need high technology because algae based biofuels, right? It is right, high capital intense and technology intense field, right? So now let's understand. See, production of algae based biofuels is possible both in seas and on continents. They can grow on marginal or non-crop land. Non-crop land में भी algae grow कर सकता है. And also on brackish or polluted water. In fact, polluted water में भी algae grow हो सकता है. So in fact, land-based systems are more developed than sea-based systems, right? So hence statement 1 is incorrect. So the production of algae based biofuels require high levels of expertise and advanced technology. The production of algae based biofuels require high levels of expertise and advanced technology, especially during the setup and construction stages. Especially during the setup and construction stages. Developing countries often face challenges in capital investments due to pre-commercial nature of this technology. Large-scale facilities are more economically viable, but are also more likely to have higher social and ecological impacts. Higher social and ecological impacts. Algae-based biofuel production requires large quantities of water. Extensive exploitation of water will have social and ecological impacts. Hence, statement 3 is correct. Right? Right? You can simply read and you can understand it, right? That is the thing. Now let's see. This is question asked in 2024, right? Related to, see, how many of the above are considered as distributed energy resources? Question on distributed energy. Again, this is not an easy question because most of the students, they don't know what is distributed energy resources means, right? So distributed energy resources, then let's read this and we will understand. So distributed energy resources are small modular energy generation and storage technologies that provide electricity or energy where you need it, right? Distributed are small modular energy generation and storage technologies. ठीक है, energy generation technologies भी है, storage technologies भी है, right? Small and modular energy generation and energy storage technologies that provide electricity or energy where you need it. That provide electricity or energy where जहां तुम्हें चाहिए वहां तुम एनर्जी जनरेट कर सकते हो और एनर्जी स्टोर भी कर सकते हो. उनको बोलते हैं डिस्ट्रीब्यूटेड एनर्जी रिसोर्सेज. दैट मींस दे आर नॉट कॉन्सेंट्रेटेड, राइट? जैसे थर्मल पावर प्लांट्स है, दे आर कॉन्सेंट्रेटेड एनर्जी डिस्ट्रीब्यूटर्स, राइट? ऑन द अदर हैंड डिस्ट्रीब्यूटेड एनर्जी रिसोर्सेज आर स्मॉल मॉड्यूलर एनर्जी, जहां चाहिए उधर एनर्जी स्टोर कर सकते हैं, प्रोड्यूस कर सकते हैं. टिपिकली प्रोड्यूसिंग लेस देन 10 megawatts of power, distributed energy resource systems can be usually be sized to meet particular needs and installed on site, right? So examples of distributed energy resources are rooftop solar panels, wind powered generations, fuel cells, right? Fuel cells, hydrogen fuel cells, small fuel cells, right? Then battery storage, then micro hydropower schemes, right? Then biomass generators, combined heat and power systems, gas and diesel power generators, then batteries in electric vehicles, open and closed cycle gas turbines, waste heat recovery systems, etc. All these are examples of distributed energy resources. All these are examples of distributed energy resources, right? These we need to remember. If we know basically, right, they are small modular energy storage or generating systems. जैसे battery storage है, छोटा battery भी है, right? That also can store, so it will be there, right? Then biomass generators, right? It can be small, right? Biomass small, right? जैसे बायोमास एनर्जी जनरेटर्स लाइक स्मॉल यूनिट, जैसे गर्भ भी चल सकता है, राइट, दे आर ऑल्सो देयर. देन फ्यूएल सेल्स, स्मॉल फ्यूएल सेल्स आर देयर, राइट, 10 मेगावाट से कम. देन रूफ टॉप solar photovoltaic effects, like it can power one light also, it can power one house also, right? So all four is the answer, right? Just if we know the definition, that is जो भी जहां भी small energy generation or storage होता है, right, they are distributed energy resources, right? Now let's see next question. See, this is again question asked in 2024. See, this is recently the term pumped storage hydropower is actually and appropriately discussed in the context of which of the following, right? So now let's discuss pumped storage hydropower. Pumped storage hydropower, right? See, first let's look at the image, right? There we will understand, then we'll come. See, this is pumped hydropower storage. Pumped hydropower storage, उसमें क्या होता है? Pumped hydropower में ये भी hydropower generation है, right? By using water we generate electricity, right? But what is the difference here? See, here what we have is, see, we have one upper reservoir, right, where water is stored, right, and we have lower reservoir, right? That is, water is there at two levels, right? Then we allow water from upper reservoir to move to the lower reservoir to a tunnel. एक टनल से इन दोनों को कनेक्ट करते हैं. अब ऊपर से पानी आएगा तो प्रेशर के साथ आएगा, राइट, फ्लो के साथ आएगा, फ्लो तेज होगा. सो जब फ्लो तेज होगा, सो इधर वी विल पुट टरबाइन, राइट. सो द टरबाइन इज देयर. सो अब जब टरबाइन रोटेट होगा, सो टरबाइन रोटेट होगा तो वी विल क्रिएट इलेक्ट्रिसिटी, जनरेट इलेक्ट्रिसिटी, राइट. सो जो भी इलेक्ट्रिसिटी यूज करेंगे, इलेक्ट्रिसिटी आएगा उसको स्टोर करेंगे एंड वी विल यूज इट. एंड whenever द सिस्टम में ज्यादा इलेक्ट्रिसिटी है, राइट, व्हेन ज्यादा इलेक्ट्रिसिटी है, तो एक और टनल करेंगे, उस टनल से ये लोअर रिजर्वायर से पानी अपर रिजर्वायर को इसी इलेक्ट्रिसिटी यूज करके पुश करेंगे टू द अपर रिजर्वायर. फिर इधर वाटर जाएगा, जो वाटर इधर आ रहा है, राइट, दैट अगेन गोस बैक टू upper reservoir, then again they come back, right? That process repeats, right? That process repeats, right? So that is the thing, right? So ये continue होगा, right? So this is the leads to electricity generation, that is pumped hydropower storage. Pumped hydropower storage, mostly this technology is used जैसे सोलर पावर में क्या है, कंटिन्यूअस एनर्जी सप्लाई नहीं होगा, राइट, इधर कंटिन्यूअस एनर्जी सप्लाई होगा, राइट. एंड जब एनर्जी ज्यादा होगा तो वही सेम एनर्जी यूज करके हम वाटर पुश करेंगे, राइट. सो दिस विल बी यूज्ड एज लॉन्ग टर्म एनर्जी स्टोरेज, राइट, लॉन्ग ड्यूरेशन एनर्जी स्टोरेज के ये यूज कर सकता है, राइट. एंड दे आर टू टाइप्स, दैट इज, वन इज ओपन लूप pumped storage and second is closed loop pumped storage, right. So open looped is what? See, there are two types, that is open looped and closed loop, right. So open loop में क्या है? See, closed loop is this one. See, ये closed loop है, right. So this loop is closed. Open loop में क्या है? इधर rather upper reservoir और lower reservoir में there will be some continuous flow of water, right, ताकि इसको कनेक्ट ना करना पड़े. जैसे मान ले इधर रिवर है, राइट, रिवर फ्लो करेगा, सो वाटर तो जाता रहेगा एंड ये ओनली वन वे फ्लो होगा, राइट. टरबाइन घूमेगी, ऊपर भी खींचने की जरूरत नहीं है. सो दैट इज कॉल्ड ओपन लूप, राइट, देयर इज नो क्लोज्ड लूप, राइट. दीज आर टू टाइप्स ऑफ pumped hydropower storage systems. Now let's go to the notes and we'll read the content. See, recently the term pumped storage hydropower is actually and appropriately discussed in the context of irrigation of terraced crop fields, no. Lift irrigation of cereal crops, no. Right, long duration energy storage, it is with respect to energy storage and rainwater harvesting system, no. Option C is the correct answer, right. So pumped storage hydropower, right, hydropower इधर है, right, it is with respect to electricity, right. We can easily eliminate options also if we don't know anything about it, right. So that is, right, pumped storage power, pumped storage hydropower, right? So from this we can say this is long duration energy storage, right? If we don't know anything also, is a type of hydroelectricity energy storage. Hydroelectricity energy storage, it is a configuration of two water reservoirs at a different elevations. So different elevations में होना चाहिए ताकि there is flow of water, right? जितना different elevation में उतना अच्छा है, right? That can generate power as water moves down from one to the other, passing through a turbine, right? There are two types of pumped storage hydropower, that is open loop pumped storage hydropower and closed loop pumped storage hydropower. Open loop pumped storage hydropower, closed loop pump storage hydropower. So open loop, either an upper or lower reservoir that is continuously connected to a natural flowing water source such as a river, right? Closed loop, off river site that produces power from water pumped to an upper reservoir without a significant natural inflow, right? That is we have discussed in the diagram, right? So now let's see this is the next question asked in UPSC 2024. Consider the following materials. Which of the above can be used as feedstock for sustainable aviation fuel? Again, sustainable aviation fuel is very important topic, right? So let's cover this comprehensively, right? So sustainable aviation fuel क्या है, क्या use कर सकते हैं? Let's understand it comprehensively, right? See, sustainable aviation fuel is a fuel that is produced from sustainable feedstocks and has chemistry similar to conventional air turbine fuel which is derived from crude oil. So air turbine fuel है वो crude oil से आती है, right? And air turbine fuel is very expensive and इससे pollution भी होती है, right? So sustainable turbine fuel है तो sustainable feedback से आती है and has chemistry similar to conventional air turbine fuel, right? So sustainable aviation fuel is a liquid fuel, right? जैसे ये एविएशन टर्बाइन फ्यूल भी लिक्विड फ्यूल है, राइट? करंटली यूज्ड इन कमर्शियल एविएशन व्हिच रिड्यूसेस CO2 emissions by 80%. सो इट सस्टेनेबल है, राइट? एक तो सस्टेनेबल सोर्सेस से आ रहा है, राइट? एंड दूसरे ये दिस इज रिड्यूसिंग CO2 emissions up to 80%, right? It can be produced from a number of sources, that is feedstock, right? Which include corn grain, oil seeds, algae, right? That means जैसे biofuel की तरह, right? Sustainable aviation fuel is a biofuel, right? It can be produced from algae. In fact, it can be produced from municipal solid waste also, right? And it can be produced from agricultural residue, forest residue, wood mill waste, right? Wood mill waste and industrial carbon monoxide waste gas, right? Industrial carbon monoxide. Then from fats, oils and greases from cooking waste and meat production, right? इनसे भी बना सकते हैं, right? That means from diverse sources, right? From diverse sources of organic waste, right? You can produce sustainable aviation fuel. So agricultural residues, corn grain, wastewater treatment sludge, right? And wood mill waste, right? From all these sources, you can generate sustainable aviation fuel, right? So then let's talk about sustainable aviation fuel. Sustainable aviation fuels can be used in existing aircraft technology with only minor modifications. So that means it is very promising, right? वो carbon dioxide emissions भी खत्म करेगी, right? In terms of efficiency, sustainable aviation fuel has same energy density. That means as conventional aviation turbine fuel. That means meaning that it can power aircraft for the same amount of time. जितना conventional aviation turbine fuel है, मान ले aviation turbine fuel से 5 hours an aeroplane can stay in the air, right? So sustainable aviation turbine fuel भी use करें तो वो 5 hours रह सकती है, right? However, they are more expensive than aviation turbine fuel, right? Aviation turbine fuel से ज्यादा expensive है. अगर कम expensive होता, right? अभी तक पूरा change कर लिया होता है, right? So worldwide, aviation accounts for 2% of CO2 emissions, right? CO2 emissions से and sustainable turbine fuel से CO2 emissions कम कर सकते हैं. And 12% of all CO2 emissions from transportation. Transportation में कितना CO2 emission है, उसमें 12% एविएशन से हो रहा है, राइट. देन इंटरनेशनल सिविल एविएशन ऑर्गेनाइजेशन, ठीक है, ये प्रोग्राम लॉन्च किया, दैट इज अगेन इंपॉर्टेंट, दैट इज कार्बन ऑफसेटिंग एंड रिडक्शन स्कीम फॉर इंटरनेशनल एविएशन, दैट इज कोर्सिया, राइट. सो इट हैज इट्स स्कीम, दैट इज इसका एक इनिशिएटिव ले लो, राइट. इंटरनेशनल सिविल एविएशन ऑर्गेनाइजेशन का कोर्सिया कोर्सिया caps net CO2 aviation emissions at 2020 levels through 2035. That means 2035 तक, ठीक है, जितना 2020 में CO2 emissions हुआ है, राइट, उसको कैप करेंगे, मतलब उससे उसी लेवल पे CO2 emissions रखेंगे, उससे ज्यादा emit नहीं करेंगे. That is 2022 में whatever we have emitted, how much CO2 we have emitted, by 2035 we will emit that level only or less, not more than 2020 levels, right. That is their commitment. And Corsia does not apply to domestic aviation, so this is only for international aviations, so not for domestic aviation, right. So international aviations may this is applied, right. So that is the limitation, right. So Corsia, right, carbon offsetting reduction scheme for international aviation, right, international aviation, right. So to achieve Corsia, sustainable aviation fuel usage is very crucial because it can reduce CO2 by 80%. See, 80%, not eliminate, reduce by 80%, right. Then International Civil Aviation Organization क्या है? That is a specialized agency of UN that coordinates the principles and techniques for international air navigation. So ICOO is established in 1947, headquarters located in Quebec, Canada, right. Specialized agency of UN, right, which works in civil aviation field, right. So that's it. Now let's study carbon trading. Again, very important topic, right, very important topic, right. We will be dealing it with comprehensively, right. See, now let's study regarding carbon trading. See, carbon trading is a mechanism with which we can address climate change, right, or which we can use to reduce greenhouse gas emissions, right. So let's understand the entire concept. It is again a very important concept, right. See, carbon trading is the process of buying and selling permits and credits that allow the permit holder to emit carbon dioxide. So if you have a permit, right, carbon trading is process of buying and selling a permit that allows permit holder to emit carbon dioxide, right. We'll understand it, right. So the most used carbon trading model is cap and trade model. See, cap and trade model. See, carbon trading is what? Say there is company A and say there is company B, right. So now company A and company B, if company A has permit, right, permit which is equivalent to say 1 ton of CO2, right. So that means the company A now can, permit holder can emit, see, this company A can emit 1 ton of CO2, right, 1 ton of CO2, right. So and now see, company B doesn't have a permit, so what it can do, it can buy permit from, जैसे कंपनी ए को रिलीज करना ही नहीं है CO2, राइट, ये ग्रीन कंपनी है, राइट. सो नाउ कंपनी बी कैन बाई परमिट फ्रॉम कंपनी ए से खरीद के, देन कंपनी बी कैन emit 1 ton CO2, right. So that is that buying and selling of permits and credits that allow permit holder to emit carbon dioxide is called carbon trading. Basically you are trading carbon, right. CO2 emission कर सकता हूं, emission नहीं कर सकता हूं, right. That permit and that credit is called carbon trading, right. Famous model of carbon trading model is cap and trade. So now let's understand what is cap and trade, right. See, cap and trade. So here first is setting up of cap, setting a cap, that is an overall limit or cap is set on amount of emissions allowed. So say there is a company A and company B. So overall the cap limit is produced, right? Limit is there for all the companies. So 100 is a limit. 100 is a limit. भाई तुम 100 tons of CO2 तक emit कर सकते हैं, right? That is a cap, right? Overall limit or cap is set on the amount of emissions allowed, right? 100 tons. Let's say 100 tons, right? Now issuance of permit, that is government issues permit up to the agreed limit. So government has issued permit, right? 100 tons emit कर सकता है. So company A के पास भी permit है, company B के पास भी permit है. So that is government is issuing. Each permit is usually measured in terms of 1 ton of CO2 equivalent. So the permit limit is 100 tons of CO2 equivalent, right? So government has given permits, right? जैसे 100 permits दे दिया government, right? So 100, company A has 100 permits, company B has 100 permits. Then cap हो गया. Then trade. So here trade is selling and buying of permits. जो भी permits है, अब company A के पास 100 permits है, company B के पास 100 permits है, right? So selling and trading, that is if the company curbs its own carbon significantly below the cap, it can trade the excess permit on the carbon market for cash. If not, may have to buy extra permits. अब देखो कंपनी ए ने मान ले out of 100 permits it only used 90 permits, right? That means it only emitted 90 tons of CO2, right? 90 tons. So now it is left with 10 tons of CO2. So this 10 points, if company B is, on the other hand, say company B is releasing 110 tons of CO2 अब भाई ये लिमिट से 10 ज्यादा कर लिया. सो ये 10 कंपनी ए से कंपनी बी खरीद सकता है बाय गिविंग कंपनी ए द कैश, राइट? सो दैट इज cap and trade. So you can trade your excess or low, that is a cap and trade, right? Then Kyoto Protocol incorporated cap and trade model of carbon trading. So Kyoto Protocol, we will be studying UNFCCC Kyoto Protocol, right? So Kyoto Protocol has adopted cap and trade model of carbon trading, right? So now let's discuss Kyoto Protocol and carbon trading, right? First time carbon trading is introduced in Kyoto Protocol, right? So Kyoto Protocol is an agreement made under the UNFCCC, right? We will be studying in the next 2 classes. We will be going for UNFCCC and Kyoto Protocol, etc. Next 2-3 classes, right? So Kyoto Protocol we will be discussing there. So Kyoto Protocol is an agreement made under the UNFCCC, right? 1997 में. So that is countries that ratify this protocol commit to reduce their emissions of carbon dioxide and other greenhouse gases like methane, nitrous oxide, sulfur hexafluoride, hydrofluorocarbons and perfluorocarbons, or engage in carbon trading if they maintain or increase emissions of these gases. If they maintain or increase. So basically countries ने क्या commit किया, right? So developed countries Kyoto Protocol में, right? You can write it, developed countries agreed. हम उधर भी डिस्कस करेंगे. Developed countries agreed overall 5% reduction, right? Compared to 1990 levels का 1990 levels, right? over 5-year period, right? That is 2008 to 2012. Over 5-year period here, that is 2008 to 2012. So under Kyoto Protocol, developed countries, that is 37 developed countries है, right? We will be studying developed and कैसे divide किया, right? They agreed for 5% reduction of their CO2 and other greenhouse gases reduction 1990 level में जितना है, right? वो 5 years, over 5 years में 5% each year reduction करेंगे, right? They have agreed, right? So under the protocol, governments are separated into two general categories, right? That is countries among developed nations referred to as Annex 1 countries, right? So Annex 1 countries, so countries Kyoto Protocol में countries are divided into Annex 1 countries and non-Annex 1 countries. So countries Annex 1 countries has developed nations, that is 37 developed nations, right, who have accepted greenhouse gas emission reduction obligations and must submit an annual greenhouse gas inventory. So Annex 1 countries. And the countries among developing or least nations referred to as non-Annex 1 countries. So non-Annex 1 countries and Annex 1 countries. So Annex 1 countries है उनको कम करना है, right, and agreed, right, जो 5% कम करना है, right, 1990 level से, right. Then non-Annex 1 countries who have no greenhouse gas emission reduction obligation but may participate in the clean development mechanism. They can participate in the clean development mechanism. What is clean development mechanism? We will be studying it. So that is the Kyoto Protocol. So Kyoto Protocol introduced three mechanisms in order to achieve its goal. So its achieve goal, three mechanisms it has included. That is clean development mechanism, joint implementation, and emissions trading. See, these three you need to remember. We will be understanding. So now, right now, what we have understood about Kyoto Protocol. So Kyoto Protocol mein countries are divided into two categories. That is Annex 1 countries and non-Annex 1 countries. Non-Annex 1 countries. Right? Annex 1 countries have 37 developed countries. Since these developed countries are mostly responsible for climate change, they agreed to reduce climate change, that is greenhouse gases, 5%, right, from 2008 to 2012. That is 10 साल के बाद, Kyoto Protocol का 10 साल के बाद 5 साल के लिए हम 5% रिडक्शन करेंगे, right. That is very less, right. Then non-Annex 1 countries, उनका कोई रिडक्शन का obligation ही नहीं है. These are mostly developing and least developed countries, right. अब ये because they need coal power, right, so they don't have any obligation. So that's what we have understood till now. Then now after that, what we have understood is ठीक है. Then see, now Kyoto Protocol. So to implement that, Kyoto Protocol introduced three mechanisms in order to achieve its goal. That is clean development mechanism, joint implementation, emissions trading, right. So now let's understand these three mechanisms. What 5% reduce करने के लिए या थोड़ा उसके लिए. So first is clean development mechanism. So clean development mechanism, important, clean development mechanism. So clean development mechanism allows countries with commitments. That is countries with commitments are, they are developed countries, right. That is the 37 countries, right, 37 countries, right. They under allows countries with commitment, that is 37 developed countries under Kyoto Protocol, to invest in emission reduction process, in developing countries and earn certified emission reduction. So these are important. Certified emission reduction credits. ठीक है, ये credits मिलेंगे, right. Example जैसे see, developed countries can invest in rural electrification project using solar panels. So clean development mechanism means, see, if developed countries can invest in clean development in developing countries, and for that they can get certified emission reduction CER credits. They can get CER credits, right. ताकि आपको आप वो बेच सकते हो, right. So you will get credits. Those credits you can sell in your countries or to other companies, right, right. So that is the mechanism, right. Clean development mechanism, where developed countries can invest in developing countries in the clean development projects, right. जैसे example, developed countries can invest in rural electrification project using solar panels. So by doing that, say USA is doing it. So USA get credits, USA get certified emission reduction credits, right, which they can use, right, which they can use to show their reductions, right. उनका 5% target reductions meet करने के लिए, right. So that is the first mechanism, clean development mechanism to achieve the goal. Then next is joint implementation, right. Next is joint implementation. So joint implementation is facilitate emission reduction between projects between industrialized countries. So industrialized countries इसमें क्या है? So joint implementation allows industrialized Annex 1 countries to carry out joint emission reduction with other industrialized countries earning emission reduction units. So the joint implementation means, so two developed countries, right? Two developed countries, right? Two developed countries, say out of the 37 countries, two developed countries allows to carry out joint emission reduction projects. Two developed countries can join together, say Germany, right? Say Japan. They can join together and they can carry out joint emission reduction projects. Joint emission reduction projects, say they can invest in solar power plant, right? Solar power plant, right? Then does earn emission reduction units. So does earn emission reduction units or emission reduction credits milenge. So that they can show that and they can show कि हम 5% reduction कर रहे हैं, right? So that is the second one, that is joint implementation, where two developed countries are joining. So joint implementation, jointly they are implementing to reduce greenhouse gases. The next is emissions trading. Emissions trading, that is the international emission trading scheme. International emission trading scheme, right? Under the Kyoto Protocol, the international emission trading scheme under the Kyoto Protocol enables countries to trade emission allowances to meet their Kyoto Protocol targets. So emission trading allows countries with surplus emission allows to sell them to countries that are over their targets, thus providing flexibility in meeting their commitments under the Kyoto Protocol. This is basically जैसे cap and trading type. जो मान ले USA has committed 5% reduction, right? So Germany also committed 5% reduction. So if USA couldn't meet that 5% reduction, right? 5% reduction, and Germany has gone for 10% reduction, right? 10% reduction. Then from Germany, USA can buy. USA can trade, right? So USA can buy Germany का कि भाई इतने units का CO2, right? So मेरे को भेज दो, right? So that is emissions trading. That is just like cap and trading type of a model, right? So emissions trading, the international emission trading scheme, that is between two countries, they can trade, right? Their CO2 credits, right? So उससे उनका targets meet हो जाएंगे. So Germany has already fulfilled its targets. It can sell to US, right? Which cannot reduce 5%. So by buying, it can fulfill its commitments, right? So these are the three mechanisms, right? Under Kyoto Protocol. Then, right, that is Kyoto Protocol is from 2008 to 2012, right? That is for 5 years, right? So after that, and Kyoto Protocol is not successful, right? So now in Paris Agreement, that is in 2015, right? So they have come up with other scheme of carbon trading, right? Other scheme of, so Paris Agreement and carbon trading will be studying. So that is Article 6. Under Article 6 of Paris Agreement, contain three separate mechanisms. So Kyoto Protocol में भी 3 mechanisms है, इधर भी 3 separate mechanisms for voluntary cooperation. इधर कुछ वो नहीं है, right? There is no compulsory voluntary cooperation towards climate goals, right? Out of 3 separate mechanisms, 2 are market mechanisms, 2 are market based, and third one is non-market based. So Paris Agreement also has 1, 2, and 3 mechanisms, right? So 3 mechanisms, right? First 2 are market mechanisms, and third is non-market mechanisms, right? So Article 6, again very important, it can be asked in mains also, right? Article 6. So now let's understand. So first mechanism is internationally transferred mitigation outcomes, ITMO, right? You need to remember this, ITMO, internationally transferred mitigation outcomes. So that is the first market mechanism 1. right? So it is covered under article 6.2. See, article 6, article 6.2, and the second is article 6.4, and it is article 6.8. So double होते जा रहा है, right? So under article 6.2, market mechanism. So we have discussed two market mechanisms. So this is first one, that is market mechanism, right? So it sets up a carbon market which allows countries to sell any extra emission reductions they have achieved compared to their nationally determined contribution targets. Nationally determined contribution targets. See, ये क्या है? We will be studying in the Paris. See, basically I will briefly explain it. See, what happened is, see, here in Kyoto Protocol, the 5% target is set, right? So in Paris Agreement, what is done is every nation is asked to spell out their own intended nationally determined contributions, right? तुम कितना कम करोगे, right? ग्रीन हाउस गैसेस कंट्रीज को खुद बताओ, राइट? कंट्रीज जैसे इंडिया कितना कम करना चाहती है, सो इंडिया यू टेल अस, राइट? सो पेरिस एग्रीमेंट में यही बोला, सो एवरी कंट्री यू टेल अस हाउ मच यू कैन रिड्यूस, right? How much you can reduce. So each country has spelled out nationally determined. So that is nationally, every nation has determined their own contributions, right? So nationally determined contributions वो बताया. अब मान ले इंडिया has spelled कि हम लोग 1000 यूनिट्स कम करेंगे. Let's say example, right? So India has said we will reduce 1000 units of CO2. Now if 1000 units of CO2, right? Now if India has reduced say 2000 units of CO2, right? 2000 units of CO2, then India can sell, see, 10,000 intended contribute, हमने promise किया, अब 2000 कम किया, so we have more 10,000 और ज्यादा कम किया CO2 units, so we can sell them, we can sell these 1000 units to some other country, right? So it sets up a carbon market, एक market set किया, right? Which allows countries to sell any extra emission reductions, right? They have achieved compared to their nationally determined contributions. ठीक है, जैसे USA achieve नहीं किया तो US can buy from India, right? So this is a voluntary direct bilateral cooperation between countries. So between any countries, जैसे जापान चाहिए तो जापान खरीद सकता है, right? India. So this is a voluntary bilateral cooperation between countries, right? Between दो countries के बीच का है, right? कोई country बेचेगी, कोई country खरीदेगी, etc., etc., right? So this is internationally transferred mitigation outcomes, right? Then next is sustainable development mechanism, right? Sustainable development mechanism, right? So this is also a market mechanism too, right? So we have discussed three mechanisms are there, two are market, so first, and this is market, so under article 6.4, right? So it is covered under article 6.4, that is sustainable development mechanism. It would create a new international carbon market for trading of emission reductions created anywhere in the world by public or private sector, right? अब देखो ये क्या है, दो कंट्रीज के बीच में, राइट? उनका नेशनली डिटरमाइंड, कंट्रीज एज ए होल, राइट? सो ये कंट्रीज के बीच में बाइलेटरल कोऑपरेशन है ये, राइट? इंटरनेशनली ट्रांसफर्ड मिटिगेशन आउटकम्स इज ए बाइलेटरल कोऑपरेशन. दो कंट्रीज का बात है, बिकॉज नेशनली डिटरमाइंड कंट्रीब्यूशंस तो कंट्रीज ही अनाउंस किया, राइट? बट ऑन अदर हैंड दिस इज पब्लिक और प्राइवेट सेक्टर, राइट? एक मार्केट क्रिएट किया, ये न्यू इंटरनेशनल कार्बन मार्केट फॉर ट्रेडिंग ऑफ, अगेन ट्रेडिंग भी इधर 1 CO2 टन, वो ट्रेडिंग होगा, ट्रेडिंग ऑफ एमिशन रिडक्शंस क्रिएटेड एनीवेयर, राइट? दिस इज इंपॉर्टेंट, क्रिएटेड एनीवेयर इन द वर्ल्ड बाय पब्लिक और प्राइवेट सेक्टर, कहीं भी, जैसे डेवलपिंग कंट्री हो सकता है, डेवलप्ड कंट्री हो सकता है, राइट? कहीं भी वो हो सकता है, राइट? सो द सस्टेनेबल डेवलपमेंट मैकेनिज्म सीक्स टू रिप्लेस क्योटो प्रोटोकॉल्स क्लीन डेवलपमेंट मैकेनिज्म. सी, क्लीन डेवलपमेंट मैकेनिज्म में क्या हो रहा है, राइट? क्लीन डेवलपमेंट मैकेनिज्म में, राइट, दे डेवलप्ड कंट्रीज आर इन्वेस्टिंग इन डेवलपिंग कंट्रीज, राइट? इन्वेस्टिंग इन डेवलप्ड कंट्रीज फॉर ग्रीन प्रोजेक्ट्स. सो इधर क्या है, इधर एनीवेयर, any country, any public or private sector be included है, right? So it has replaced the clean development mechanism of Kyoto Protocol, and rather it is called sustainable development mechanism. Anywhere, any time, right? You can invest in carbon trading, right? Emission trading. In contrast to direct bilateral cooperation under mechanism 1, ठीक है, mechanism 1 में bilateral cooperation under mechanism 1, this mechanism will be supervised by a body designated by UN Conference of Parties, UN COP, right? It will be supervised, right? Basically जो private sector भी कर रहा है तो ये register तो होना चाहिए, right? So first is bilateral, so this is supervised. Another unique aspect of this mechanism is mobilizing the private sector to participate in climate change mitigation by providing suitable incentives. So another is by private sector को भी participate किया, right? Private sector भी trade कर सकती है, nations भी trade कर सकता है, any organization they can trade, right? So that is the thing. Next is third, that is non-market approach, right? दो market approaches, इधर भी market है, right? And here also market, carbon market created. So third is non-market approach. Non-market approach. So Article 6.8 recognizes non-market approach to boost mitigation, adaptation, finance, technology transfer, and capacity building. So non-market approaches recognize non-market approaches to boost mitigation, adaptation, finance, technology transfer, and capacity building in situations where no trade is involved. जैसे मान ले कोई country है, right? If a country wants to transfer its green technology to other country, right? It will be covered under 6.8, Article 6.8. Say a private company, say it is in US, its branch is also in India, right? If it wants to promote green technology in India, that is covered here, right? So non-market, so market से कुछ लेना देना नहीं है, right? So non-market mechanisms like technology transfer, finance, जैसे any country wants to transfer finances, green finances, right? ताकि green climate में invest करने के लिए से African country में USA वो fund देना चाहती है, right? To promote climate change, right? To fight climate change. So that is covered here, right? So in such situation, no trade is involved. This could involve similar activities to those under Article 6.2 or 6.4 without the element of trading, right? जैसे मान ले इसमें say one country wants to give CO2 permits to other country, right? बिना पैसे का they can involve, right, in transfer, right? Without added element of trading. Trading के बिना they can easily transfer like that, right? So that is a non-market approach. So three approaches are there, right? So under Paris Agreement, right? So we studied two are market approaches and one is non-market approach, right? Then under Kyoto Protocol also three mechanisms are used: clean development mechanism, joint implementation, and emission trading, right? So cap and trade है क्या वो we have understood, right? So now let's understand the next thing, that is geoengineering or climate engineering. Geoengineering or climate engineering करके हम climate change को fight कर सकते हैं. So geoengineering, that is engineering the earth, और climate engineering, climate को वो करने के लिए engineer कर रहा है तो that is climate engineering. So geoengineering refers to deliberate large scale intervention in earth's natural systems with an aim of reducing global warming, global warming को कम करने के लिए earth का natural system को change करना, that is called geoengineering. There are two main categories of geoengineering. They are one is solar radiation management, and second is carbon dioxide removal. So first let's understand solar radiation management, right? Solar radiation management करके, right, we can reduce global warming, right? So that is, it include techniques that are aimed at reflecting sunlight away from the earth to reduce global temperatures. देखो जैसे sunlight earth पे आ रही है, ठीक है, उसी को ही earth पे तक आने नहीं दिया, right? तो sunlight कम हो जाएगा, right? Global जो ग्रीन हाउस इफेक्ट है वो कम हो जाएगा, so that we can reduce the global temperature. So that is solar radiation management, because we are managing solar rays, sun का rays को we are managing, right? So first is stratospheric aerosol injection. राइट, स्ट्रेटोस्फियर में एरोजल्स को इंजेक्ट करो ताकि दे रिफ्लेक्ट, राइट, ऊपर ही दे रिफ्लेक्ट द सनलाइट, ठीक है, इधर स्ट्रेटोस्फियर में एरोजल इन्फेक्ट करो सो दैट दे रिफ्लेक्ट द सनलाइट, सनलाइट कम ही जितना जरूरी है उतना ही आएगा, जो टेम्परेचर मेंटेन कर सकते हैं उतना ही आएगा, राइट, सो दैट ग्लोबल वार्मिंग वोंट बी ए प्रॉब्लम, राइट, सो इंजेक्टिंग रिफ्लेक्टिव पार्टिकल्स लाइक सल्फर डाइऑक्साइड, sulfate aerosols into stratosphere to reflect sunlight, right, so that is stratospheric aerosol injection, right, stratosphere में aerosols inject करना so that they reflect the sunlight within the stratosphere only, right, so that they don't reach the earth, right, फिर earth में trap नहीं होंगे green house gases से, right, then cirrus cloud manipulation, right, here cirrus clouds are removed or thinned so that long wave infrared trapping capacity is reduced and cools the surface, right, here cirrus cloud manipulation where cirrus clouds are removed or thinned, जैसे मान ले इधर ये अर्थ है, राइट, सो हियर देर आर क्लाउड्स, राइट, अब इसको निकाल दिया क्लाउड्स को, ठीक है, जो भी सनरेज जाएंगे तो वो रुकेंगे नहीं, राइट, सो जब रुकेंगे नहीं, राइट, सो दैट वुड लीड टू ग्रीन हाउस इफेक्ट कम होगा, राइट, cirrus cloud manipulation, here cirrus clouds are removed or thinned so that their long wave infrared trapping, जो भी इधर से जाता है, राइट, अर्थ से रिफ्लेक्ट होके जा रहा है, दैट इज लॉन्ग वेव इंफ्रारेड, राइट, जो आता है दैट इज शॉर्ट वेव, राइट, वी हैव डिस्कस्ड, राइट, सो दैट इज सो दैट लॉन्ग वेव infrared trapping capacity is reduced and thus cools the surface. Next is marine cloud brightening, that is the low warm clouds which are highly reflective to sunlight are modified to increase their reflectivity, right, marine cloud, right, that is जो marine areas में cloud है, जो oceans में clouds है, right, low warm clouds which are highly reflective, ठीक है, highly reflective sunlight are modified to increase their reflectivity, उनको modify करके उनका reflectivity और बढ़ाओ, right, ताकि ocean में sunlight आए वो earth surface में ही ना, right, so marine areas low warm clouds, right, they are present in marine areas over oceans, right, उनको और bright करो ताकि reflection capacity बढ़ेगा, right, then space based reflections, that is positioning mirrors or reflective objects in space to deflect sunlight before it reaches the earth, right, space में ही mirrors लगाओ ताकि सनलाइट रिफ्लेक्ट हो जाएगा, दिस इज हाई टेक्नोलॉजी वाला चीज है, राइट, स्पेस बेस्ड रिफ्लेक्टर्स, राइट, सो these are all solar radiative management because we are managing sun's radiations, right, so that by doing that we can fight global warming, right, we can reduce temperature of earth. Then next is carbon dioxide removal, जो कार्बन डाइऑक्साइड है उसको रिमूव करेंगे ताकि ग्रीन हाउस इफेक्ट वो कम हो जाएगा, राइट, ग्रीन हाउस इफेक्ट कम हो जाएगा, सो इट इंक्लूड्स मेथड्स फोकस्ड ऑन रिमूविंग CO2 फ्रॉम द एटमॉस्फेयर टू रिड्यूस कॉन्सेंट्रेशन एंड मिटिगेट ग्रीन हाउस इफेक्ट, right, we have already studied this, right, so one is afforestation and reforestation, planting of trees to absorb CO2 from the atmosphere, so plants absorb CO2 so that will reduce greenhouse gas effect, right, then direct air capture and storage, right, we have already discussed and we have watched video also, direct air carbon capture, air से सीधा we are capturing CO2, right, so that CO2 can be converted into pellets, right, which can be converted into liquid and which can be used in car fuels, right, diesel petrol की जगह use कर सकते हैं, right, we have already, so technologies that capture CO2 directly from the air and store it underground are used, so underground भी CO2 को capture करके store कर सकते हैं, right, by that we will reduce CO2, right, carbon dioxide removal, so greenhouse gas effect कम होगा, right, then next is ocean fertilization, that is ocean fertilization is addition of nutrients example and mostly iron to enhance growth of phytoplankton, so phytoplankton are what, like plants, so they take carbon dioxide, they absorb carbon dioxide and release oxygen, right, so ocean fertilization, addition of nutrients example iron to enhance the growth of phytoplankton which absorb CO2, right, so that is ocean fertilization, addition of nutrients iron to enhance the growth of phytoplankton, right? So they absorb CO2, so उससे वो हो जाएगा, right? So these are the mechanisms. So we have discussed things which we can use to fight climate change, that is green energy, right? Renewable energy, then geoengineering, right? Then carbon trading mechanisms, right? Then carbon sequestration. Carbon sequestration is nothing but carbon dioxide removal only, right? So, right? So that's it. And with this, we are done with, and yeah, this one is also there. See, diamond dust, right? So current affairs related to the topic, right? So a new study explores diamond dust. So diamond dust as a potential geoengineering strategy for cooling of planet. Geoengineering strategy, right? That is, it proposes that spraying about 5 million tons of diamonds into Earth's upper atmosphere annually for 45 years could lower global temperatures by 1.6 degrees, right? So since diamond dust, अब diamond dust ही क्यों use कर रहा है? Research आया, right? Diamond dust, since diamond dust reflects light and heat effectively, ठीक है? Diamond dust है, diamond का dust particles, छोटे छोटे particles, they can reflect the light and heat effectively and remains airborne longer, ठीक है? हवा में ज्यादा देर रह सकते हैं, right? अच्छे से रिफ्लेक्ट कर सकता है एंड इज लेस लाइकली टू क्लम्प टुगेदर इन द एटमोस्फियर, राइट? जहां रखा है उधर ही रह सकता है, राइट? एंड दे आर इफेक्टिव फॉर कूलिंग प्लैनेट. सो ऑल्सो इट इज ए सेफर ऑल्टरनेटिव, ठीक है? उसी को क्यों यूज किया? अनलाइक अगर मान ले सल्फर डाइऑक्साइड यूज किया, राइट, विच पोजेस रिस्क लाइक एसिड रेन एंड ओजोन डिप्लीशन. एंड डायमंड डस्ट इज केमिकली इनर्ट. सो केमिकली इनर्ट है, सो देर इज नो रिस्क ऑफ पानी से नहीं मिलेंगे, राइट? सो एसिड रेन नहीं होगा, ओजोन लेयर डिप्लीशन नहीं होगा, कुछ नहीं होगा. सो डायमंड डस्ट कैन बी यूज्ड as a geoengineering technique. So this was in news this year. So this is important, right? So now with this we are done. Now in next class we will be dealing with international environmental conferences, conventions and initiatives. We will be discussing with all the things, various environmental initiatives we are taking, that is UNFCC, UNCBD, right? All the things we will be discussing, right? So next 2-3 classes again are going to be very important classes, right? Every year 2 to 3 questions are asked from international environmental conferences, conventions and initiatives, right? See you in the next class. Bye.